Okay. Okay, good evening everyone. So I'm back. So today we are going to cover some problems. I've taken around 50 problems. So this question, I mean the questions are like I've taken some questions from every topic. So looking at JEE Main's recent paper, they are trying their maximum to cover each and every topic equally in terms of weightage. So that's what I've done. So I've taken the problems in an equal weightage manner. I haven't taken like some questions from like a lot of questions from one topic. It's going to be a uniform distribution. Okay, so we will start in a bit. So in an equal weightage manner. Yeah, good afternoon guys. Okay. Okay, I guess we can start right with the first question. So first question is from error analysis. This type of problem is very common nowadays in JEE. All right. Okay, so the question is we have to find the error in measurement of density of a wire. Okay, so what is given to us? What is given to us is the mass of the wire and the radius of the wire. So this is a cylindrical wire. Okay, so the density we can easily calculate it as the mass divided by the volume, and because this is a cylindrical wire, we can write the volume as pi radius squared times the length. Okay, so now the thing is we'll use the percentage error formula. So delta rho by rho equals delta m divided by m. So they didn't mention, okay, the length is also given. So everything has some calculation error. So 2 delta r by r. Okay, so this 2 is because the coefficient of the exponent of r is 2. Okay, and then we also have delta l by l. Okay, and finally after calculating this, we'll multiply it by 100 because we want the percentage error, right? So delta m is 0.003. So if you multiply that with 100, so delta rho by rho times 100, this is what we are calculating. So this would be 0.3 divided by 0.6, right? So this is the error in mass and this is the true value. So I'm multiplying that with 100, so this would become 0.3 divided by 0.6, and for the radius part it will be 1 by 0.5. Okay, 1 divided by 0.5, and for the length part it will be 5 by 10. Okay, so this is half, so 0.5 from here, and this will give us 4, and this will give us half once again. So the answer should be 5, right? The answer should be 5%. All right. Sumit sir, question mark. Like, what is the question actually? Sumit sir is still here, guys. He will cover the discussion videos. So yeah. All right. So this question is easy. Now moving on. Now this is a slightly harder problem when it comes to error analysis. All these questions are from previous year JEE Mains only. Okay. So this, I think this is from the 2025 JEE Mains. And yeah, so this type of questions where we have a complex function like in which we have an exponential one, these are kind of harder to find when it comes to the percentage error. Okay, so we cannot use the typical delta L by L type of a formula which we used in the last page. So here what we'll do is we'll take the logarithm on both sides. Okay, so if I take ln E, this would be equal to ln of alpha cube e to the power minus beta t. Okay, and the reason for taking the logarithm will be clear soon. The main idea is that when we are talking about percentage error in any quantity, so here in E, it will be some dE divided by E, right, times 100. This is how we calculate the percentage error. But here, now once we take the logarithm, we'll differentiate it on both sides, okay? So the derivative of log of E will become 1 by E multiplied with dE, right? So this will become dE over E. Okay, so this is the advantage of taking logarithm on both sides. So for this part, let's simplify it a bit. So log of AB, we can write it as log A plus log B. So this thing will become log of alpha cube, which we can write it as 3 log of alpha. And the next term is log of e to the power minus beta t, which will just become minus beta t. So these are just the properties of logarithm. Log of alpha cube, we can write it as 3 log alpha, plus log of e to the power minus beta t would become minus beta t. Okay, so now let's differentiate this. So the 3 remains as such. Derivative of log alpha will give us d alpha over alpha, and the derivative of beta t. So in the question, what is given to us? Beta is a constant, right? And the errors are in the measurements of alpha and time. Okay, so the beta, we'll keep it as such, it's a constant, minus beta, and the error in time, so that will be dt upon t. Okay, so this is what we get after differentiating it. Beta is a constant as it is given in the question, whereas there is error in time and calculation of alpha. So now what we'll do is, because we want the maximum percentage error, we'll not put the minus here, we'll in fact do it with a plus, okay? And that's because we want the maximum percentage error in E, the quantity E, okay? It's actually energy. So now all we have to do is multiply on both sides with 100 for the percentage error. So this would become 3 times d alpha over alpha. So what is the error in alpha? The percentage error in alpha is given to be 1.2%. So d alpha over alpha times 100 will become 1.2. Okay. Next we have plus beta. Beta is 0.3, constant as such, and the error in time, percentage error in time, is 1.6. Okay. So this is 3.6% and this is 48 for, so this will be 0.48. Okay, so this doesn't match with any option. So 0.3 multiplied with 1.6. Yeah, this, if we take it approximately as 0.5, the answer would be approximately 4, I guess, right? Or are we doing any mistake somewhere? Okay, so yeah, I'm actually in the Lakshya batch, yes. No, not Lakshya batch, I'm actually taking class 4 Arjuna batch, 11th. All right, okay. Lakshya batch, I guess, would be taken by Sumit sir only. Okay, so what is the mistake here? So 3 times d alpha by alpha, so that looks fine. Percentage error in alpha is, so 3.6, and beta is 1.6. That percentage error is correct, and oh yeah, this derivative would just be minus dt, I guess, right? So if I differentiate that, oh yeah, so this would just be, okay, what is the error actually? Can you guys find the mistake? It's correct. Yeah, so the mistake is, like, while we were differentiating, this won't be, the derivative of minus beta t won't be dt by t, that's the error. Okay, so so this would just become minus dt. This would become dt, right? The derivative of t would become dt. That was the error. Now we have to convert this into the percentage error. So we'll divide and multiply with time. Okay. So now it will be correct. So now let's write it down once more. So percentage error in alpha is 1.2 and beta is 0.3, and percentage error in t time would be 1.6, but we have a 5 in the denominator, right, because we have to calculate at t equal to 5. So now it should be correct. Okay, so yeah, we'll come back to this question a bit later. T se multiply divide, yeah. Tomorrow 4 AM, can you take physics formula session, please? Let me see. Okay, I have to check. All right. Sir, are these questions enough for 30 to 40 marks? Well, oh yeah, I made that mistake. Yeah, this should be multiplied with 5. Yeah, you're right. So this will be 2.4 and this will be 3.6, right? So this is 3.6 and 8 3s are 24, 2.4, and yeah, finally it's correct, I guess, 6%. So yeah, now it's fine, first option. Okay. Yeah, 5 will be in the numerator, guys. So I'll try to take a lecture tomorrow. Okay. So let's move on. So yeah, now we have a kinematics problem. So here we have a maximum speed of a boat which is given in still water is 27 km/h. Okay, so this is the velocity of the boat relative to the river. Okay, which is the maximum value is given, and it is given as 27 km/h. Okay, so now the question is, this boat is moving downstream in a river flowing at 9 km/h. So the velocity of the river is 9 km/h. Okay, so and the boat is flowing downstream, so their velocities will get added up, right? So river flow, let's say this is the river and this is the boat. So the river flow is 9 and the boat's relative speed is 27. So their effective speeds will get added up, and the boat's net speed with respect to ground will be 27 plus 9, which will be 36 km/h. Okay. Now the thing is, there's a man in the boat who throws a ball vertically upwards with a speed of 10 meters per second. Okay, so this guy who's in the boat, he throws a ball upwards. Okay, so when in the question it's mentioned that the man throws it upwards, that is of course with respect to the boat. Okay, so the guy is moving with the boat and he threw the ball upwards with 10 meters per second. So if this is the ball, it will have the 10 meters per second which the man gave, but this was with respect to the man and the man was moving with 36. So with respect to the ground, the ball will also have a 36 kmph to the right. Okay, so this is the ground frame velocity of the ball. This is our ball. All right, so now the question is, now it's going to move in a projectile type motion. So we have to find the range of the ball as observed by an observer at rest on the river bank. Okay, which just means with respect to the ground frame. Okay, so now it's a simple projectile motion problem. So the ball has uy as 10 and ux as 36. Okay, so we can easily find out the time of flight. It will be 2 uy by g, which is, so time of flight is 2 times uy divided by g, which is 2 seconds. And once we have the time of flight, the range is ux into time of flight, right? So the range will be 36 into 2, 72 meters. Okay, so that will be the range. Okay, so 72. Oh yeah, the unit issue, right? Yeah, I didn't observe the units. So 36, we have to convert it. 36 would be, if you multiply with 5 over 18, this will also be 10. Okay, so range would in fact be 10 meters per second times 2, which is 20 meters. All right, so now the question, I guess, wanted it in centimeters. So 20 times 100 is 2000. Okay. Yeah, meters per second. Yeah, I did my graduation from IIT Madras. My name is Gokul, by the way. Like, I guess, yeah, it wasn't on the slide. So yeah, let's move on. So now we have a particle, another projectile question, I guess. Particle projected at an angle of 30 from the horizontal at a speed of 60 meters per second. Okay, so projection speed is 60 meters per second, angle of projection is 30. So the question is, the height traversed by the particle in the first second is h naught. In the first second is h naught, okay, and the height traversed in the last second before it reaches the maximum height is h1. Then that ratio is. So this is the classic formula which we discuss in one-dimensional kinematics, which is the distance traveled in the nth second, right? The displacement in the nth second. So this guy's formula was u plus 2n minus 1 a divided by 2. Okay, so this is the distance traveled in the nth second. So what does nth second mean? So second starting from 0 to 1, this is the first second, right? So you'll put n equal to 1 there. What you will get is the distance traveled from 0 to 1 second. Okay, so we'll use that here. So the distance traveled in the first second in the y direction, the height traversed, is given to be h naught. So h naught will be, so we'll apply this equation just in the y direction. So initial y velocity, so that will be 60 sine 30, which would be 30. G will be in the downward direction, so we'll put it with a negative sign. So G, if I take it as 10, so 10 by 2 is 5. And because this is the first second, we'll put n equal to 1, so 2 minus 1 is just 1. So the answer is going to be 25 meters. So this is the height covered in the first second, it is 25 meters. Now the question is, the next part is before it reaches the max, 1 second, I guess, yeah, in the last second before it reaches the maximum height. So when does the particle reach the maximum height? So if this is the particle, and let's say this is the max height point, this point is reached after a time of flight divided by 2, right? So time of flight will be 2 uy by g, so 2 into uy will be 30 divided by 10. So this is 6 seconds, right? So the particle reaches the topmost point after 3 seconds. Okay, so what does the last second be? So 0 to 1, 1 to 2 and 2 to 3, right? So in the nth formula we would put n equal to 3, right? 0 to 1 second is the first second, 1 to 2 is the second second, and 2 to 3 is the third second. Okay, so in the n formula, Sn formula, we will put n equal to 3. That is given to be h1. So h1 is 30 minus g by 2, 5, multiplied with 6 minus 1, which is 5. So 30 minus 25 is 5. The ratio of h naught divided by h1 is going to be 5. Okay, so this answer is 5. Okay, so I hope that is clear. Okay, so I have to be even more fast. Okay, so you saw my previous lecture, it was helpful. Okay, great. Okay. So do you guys want me to cover it even faster, or is this fine? Okay, so now we have a conical pendulum situation. So a string of length L. So basically the conical pendulum situation, what is given is this mass makes 3 by pi rotations per second. Okay, so this is the rotation that they're talking about. This is one rotation. So it makes 3 by pi rotations every second. So you can kind of think of it as the omega of the circular motion, and that is 3 by pi rotations per second. Okay, so one rotation is 2 pi radian. So if I multiply this with 2 pi, I'll get it as radians per second. So this is going to be 6 radians per second. Okay. So now the question is, what is the tension in the string? Okay. So it's a simple FBD problem. We'll draw the side view. So this is, let's say, that axis, and this is going to be the string, and here we have the mass. Okay. So the length of the string is given to be capital L. This angle is theta, and this mass has a velocity, right? So the velocity of this mass, we can get it. So if this is L, this is theta, this distance is L sine theta, and we know the omega of the circular motion, it is 6. So the velocity will be omega into L sine theta. So I guess L is not given, but that's fine. So this is the tension. Nothing about the mass is also given. So this is mg. So these are the two forces acting on the particle, right? This angle is theta. So this component is t cos theta, and this component is t sin theta. Now t cos theta balances out mg. Because the ball is in vertical equilibrium, and this t sin theta provides a centripetal acceleration, right? So t sin theta will be mass times the centripetal acceleration, which is v square by r. So, or we can also write it as r omega square. So the radius of the circular motion is L sin theta. So L sin theta times omega square. Omega was 6, so this would be 36. So now we can just divide these two. Okay. No, actually we need tension in terms of ml, right? So we'll square and add both of them. So we'll get t square on the left side, and on the right hand side we get m times, okay, so here it will be g square plus oh, actually we just needed this equation. So sin theta cancels out, and we get the tension as 36 ml. Okay, so they wanted the answer in ml, so the answer will be just 36. Okay. All right. Moving on. So next question, mass m slides without friction on the wall of the vertical circular hoop. Radius r. Bead moves under the combined action of gravity and the massless spring attached to the bottom of the hoop. So the spring is attached over here, it's massless, and it's attached to this mass. Okay. Now the equilibrium length of the spring is r. So at the moment it's elongated by r. So elongation in the spring will be r. If the bead is released from the top of the hoop with negligible initial speed, so initial speed 0, velocity of the bead when the length of the spring becomes r would be. Okay, so if we, let's say, release the bead and the bead starts moving along the circular path, at some point the length of this spring would become r. Okay, so let's say that happens somewhere over here. Okay, at this instant the length of the spring becomes r. At this instant we need the speed. Okay, that is a question. So because the particle is moving in the circular path, the speed will always be tangential to the circle, right? Like this. So let's say the speed is some v. What is the final, this is a simple energy conservation problem, because what are the forces acting on the particle? There is the normal force which does no work, there is gravity, there is a spring force, right? So spring force and force of gravity, we can include it as potential energy. So we can say change in gravitational potential energy plus change in spring potential energy equal to plus change in kinetic energy equal to 0, okay? Simple energy conservation. So the bob or the ball, we have to find how much did it came down by. So this distance is r, so this is a little bit of geometry. So this is, let's say, that spring in the final situation. This is the center of that circular path. So I am connecting these 2 points to the center of the circle, okay? So this length is r, this length is also r, this length is also r, which means this is an equilateral triangle in the final situation. So if this angle is, let's say, 60, can we find out the height, right? Because we need the height change to write the change in gravitational potential energy. This is where the mass is at the moment. So let's find out its height from the ground. So this distance is r cos theta, which is r by 2, right? So this, if this is the center of the circle, this height is r by 2, okay? And this height was obviously r. So basically the mass m, it fell down by a distance of r plus r by 2, which is 3r by 2. So the change in gravitational potential energy is minus mg multiplied with 3r by 2, right? The gravitational potential energy dropped. So how many questions? I think 50 at least we will cover today. So what about spring potential energy? So initially spring was elongated by r. Finally, because the length of the spring is r, natural length of the spring is also r. So finally elongation is 0. So finally the potential energy of the spring is 0. So change in spring potential energy will be final spring potential energy minus initial, which would be negative. So negative half k r square. This is the change in spring potential energy. This plus change in kinetic energy. So initially kinetic energy is 0, finally it will be half mv square. So plus half mv square equal to 0. So now we'll just have to solve this, okay? What are they exactly asking? The velocity of the bead, okay? So we'll need to solve for v. So v square, so 2 cancels out. So v square will be equal to kr square by 2, kr square by m plus 3gr. Kr square by m plus 3gr, option A is the correct answer, okay? It's okay, Keshav, it's okay. You can always watch the Sir Kal wale questions. I actually don't have those questions, Navya. Well, I mean, today's collection is also very good. It's not like if we do the yesterday's problem, it will be repeated in the next shifts. So yeah, oh yeah, let's move on. Okay, so this is a center of mass problem. We have to find the center of mass of this rectangular sheet. Sigma is given, so it's a function of x. Sigma is sigma naught x divided by AB. So in this rectangle, the base length is A, the height is B. We have to find the center of mass coordinates, okay, with respect to this origin. So here the idea is the mass varies with x. So as you can see, if I try to plot this sigma function, it will be like a straight line, right? Sigma naught x by AB. So it's kind of like a y equal to mx type of a line. So which means as we move along the x-axis, as we go away and away from the origin, the mass increases. So here the mass density is very high, here the mass density is low, which means the center of mass will be somewhere to the right of A by 2, right? So, and if I go along the y direction, there is no change. So if I take a tiny strip something like this along the this strip with a length a and let's say width delta y. So if the center of mass of this strip is somewhere over here, let's say, right, it will be to the right of the a/2 point, right, because there is more mass density to the right of a/2. So if I take another strip over here, a different strip with same width delta y, its center of mass will also lie exactly here, right, because the mass distribution is identical. So which means if I take such strips, all of their individual center of masses will be exactly at this location, or I should say exactly at the same x coordinate. So which means the y coordinate of the center of mass will be exactly at the middle point, right, because all of these are exactly at the same y coordinate, same x coordinate, which means their effective center of mass will be exactly at the middle, which is b/2. Okay, so the y coordinate is pretty easy to understand. It is exactly at b/2 point. Okay, so the y coordinate will be b/2. The question is, what is the x coordinate? That is what we have to find. So for the x coordinate, the thing is, when we have a distribution like this, in which the mass distribution varies as a function of x, which means it's a y equal to mx type of a distribution, right? The sigma is, if I write it like this, the sigma is something like this, the straight line. You can either use the formula as well for x coordinate of center of mass, or the thing is, we'll use the fact that this is a right triangle. Okay, this mass distribution is kind of like, it forms a right triangle. If the base is a, so this is the origin, this is a comma 0. So if in a right triangle, if you guys have learned, the centroid lies at 2a/3, right? The centroid of the right triangle, it lies at distance of somewhere over here. The x coordinate of the centroid is 2a/3. Okay, now this is only true because the distribution is proportional to x, which means we get a straight line, and the centroid of this right triangle will be at 2a/3. Now because of that, we can say the center of mass x coordinate will be 2a/3, and the y coordinate is of course b/2. Okay, now otherwise the other approach is of course using the XCOM formula, the usual integral x dm upon integral dm formula, okay, which is not needed for this question. It will be a bit lengthy. Yeah, the answer will be option A. Okay, so now we have a circular disc whose radius is 20 centimeter with center located at the origin. A circular hole of radius 5 is cut from the disc. So if I say 5 centimeter equals r, then the radius of the disc is 4r basically. It is cut such that the edge of the hole touches the edge of the disc. Okay, so the diagram will look something like this. This is the disc. If this is, let's say, the center, what is the radius? It's 5, right? So the hole will look like this. It will touch the circle and it will also touch the center. Okay, radius of the bigger circle is 20. No, actually it won't touch the center. Yeah, it will be something like this. Okay, because the radius of this disc is 5, so this length will be 10, whereas the radius of the disc is 20, so this length is 20. Okay, so this is how the diagram will be. This is the center of the hole, this is the center of the disc. Now the question is the distance of the center of mass from the residual or remaining disc from the origin. So if this hole was not there, the center of mass will be at the center of the disc. right? So this is my origin, this is the center of the hole, okay? So yeah, so basically the radius of the bigger disk, we are taking it as 4r. So this will be r, this is going to be 2r, and this is also r, so the radius of the larger disk will be 4r. Okay, so now the thing is, first we'll discover the mass of, first let's say the sigma of the disk is sigma, the mass per unit area. So if I say the mass of the larger disk without the hole, right, the mass of the larger disk without the hole, if I say it is equal to m, then basically I am saying sigma times pi into 4r the whole square is equal to m, right? Then what is the mass of the smaller disk? It will be, of course, this particular whole disk, it will be sigma pi r squared, and so this is of course 16 sigma pi r square, which means this would be m by 16. Okay, so if the mass of the full disk is capital M, mass of this hole is m by 16. That is something that we can observe. So m by 16 mass is removed from this m mass disk. So now we can use the center of mass formula. So this is of course my origin. So x coordinate of the new center of mass, it will be, so what we are doing is some sort of a superposition. First we'll assume that there was the full disk with us, no hole present, and that full disk mass was capital M. So that capital M, where is that capital M's center of mass? At the origin. So this multiplied with 0, m1 x1. Now we'll assume that there is a negative mass of m by 16 over here, this hole, this is a negative mass of m by 16. So we'll put a negative sign here, so minus m by 16 multiplied with, what is the x coordinate of the center of mass of the hole? It is 2r plus r, which is 3r. So this would be 3r divided by m1 plus m2, which is m minus m by 16 or 15 m by 16. Right, so now it is going to be minus m by 16 into 3r divided by 15 m by 16. So the m by 16 cancels off, 3 and 15 cancels off, and we get minus r by 5 as the answer. So which means from the origin, the center of mass is to the left by a distance of r by 5. R was 5 centimeters, so this will be minus 1 centimeter. Okay, so option 3 will be the answer. Okay. All right. Now moving on, is a collision problem. So we have a bob of a pendulum having massless string of length capital R, is released from 60 degree to the vertical. It hit another bob B of half the mass. Okay, so B's mass is m by 2. This B is actually in the ground, by the way. It's not mid-air, it's actually in the ground. We are assuming elastic collision. The magnitude of the velocity of bob A after the collision will be, so A is over here, B is over here, A collides with B, and then A will have some velocity after collision. We have to find that velocity. So that is the question. So let's begin. So first, before getting into the collision idea, we have to calculate the velocity of this mass m when it reaches the bottommost position. So this is length r, so we can easily find out the height from the top, right? So this will be r cos theta r by 2. So when the bob reaches the ground, what is the drop in height? It will be r minus r by 2, which is r by 2. So ball A falls down by r by 2. So which means we can easily use energy conservation. Half m v square, the final velocity square, equals mg into height dropped. Height dropped will be r by 2. So which means v square is square root gr. V is root gr. Okay, so now we can take a look at the collision happening. So this is ball B and this is the ball A. Ball A is going to have a leftward velocity of root gr. Ball B is at rest. Okay, so now they are going to collide and B will have some velocity to the left. Let's call it VB. And A will have some final velocity. Let's call it VA. Okay, so this is an elastic collision problem now. So first we'll conserve momentum. A's mass is m, B's mass is m by 2. So m root gr equals m by 2 VB plus mVA. This is the momentum conservation expression. Okay, now we'll do the E equals to 1 expression, right? Velocity of approach equals velocity of separation when it comes to low voice. Is voice fine? Oh yeah, brightness, okay. Brightness, screen ka brightness. Please increase the speed, okay. Brightness thoda लो था. कुछ कर सकते हैं? Brightness. Okay, so we'll speed it up. So yeah, now we'll write the velocity. Now the velocity of approach equals velocity of separation. So root gr equals VB minus VA. Okay. So I guess like if we want to increase the speed, we can do one thing. I can explain the concepts and you guys can do the calculations, right? I'll also just mention the answer. Will that be okay? Just say yes if you guys would like that, or do you want me to do the calculations as well? Okay, so then we can just, yeah, so basically we have two equations and two variables in VA and VB now. So all you have to do is find VA and that will be the answer, okay. Alright, so I will avoid the calculations. So the answer will be 1 by 3 square root Rg once you calculate, alright. Alright, let's move on. So now uniform solid cylinder, mass m, radius r, rolls along an inclined rough plane of inclination 45. If it starts to roll from rest from the top of the plane, then the linear acceleration of the cylinder's axis will be. Acceleration of the center of mass is what they are asking. So this is the cylinder, it's rolling, okay, and it starts from rest. So it has nothing to do with the velocity, we just have to find the acceleration. Okay, its mass is m, solid cylinder, radius is r, inclination angle is 45 degree. This angle is 45. So basically when we want the acceleration, we just first find out the angular acceleration of this cylinder. So it will have some counterclockwise angular acceleration, and the best way to find this will be to use the instantaneous center of rotation, which is basically the contact point. Okay, this is the ICOR. So at the center, the forces are mg sin theta, and mg cos theta directly passes through the ICOR. Normal reaction passes through the ICOR, friction passes through the ICOR. So the only force left is mg sin theta. So it's easy to calculate the torque about the ICOR. So this distance is r. So the clockwise torque will be mg sin theta multiplied with r. This will be equal to the moment of inertia about ICOR. This is a solid cylinder. So about the central axis, the moment of inertia will be mr square by 2. We have to add an mr square, which is 3 mr square by 2, 3 by 2 mr square alpha. So from here alpha will come out to be g sine theta by r times 2 by 3. 2 by 3 g sine theta by r, and r alpha will give us this acceleration of the center of mass, right? ACM is simply going to be r alpha, which is 2g by 3 sine theta is 1 by root 2. So root 2 divided by 3g, option 3 will be the answer, okay? So moving on, Earth has mass 8 times and radius 2 times that of a planet. If the escape velocity from the Earth is 11.2, this is the famous result, 11.2 kilometer per second, the escape velocity from that planet would be. So escape velocity, the formula of escape velocity is square root 2gm by r, okay? So the other planet, so let's say the mass of the planet, the second planet is m and its radius is r. It's given that the mass, Earth has 8 times the mass m. So for Earth, the mass is 8m and the radius is 2r, twice the radius of the planet, okay? Now for Earth we know the escape velocity. So escape velocity of Earth, of the planet, divided by escape velocity of Earth, this will be square root of 2g is a constant, mass of planet divided by radius of planet times radius of Earth upon mass of Earth. Okay, so this will be it. So radius of Earth is 8m, mass of Earth is 8m, radius of Earth is 2r, and this is m and r. This is m, this is r. So now everything just cancels out. This is 1 by 4. Square root of 1 by 4 is half. So the escape velocity from the planet P will be escape velocity of Earth divided by 2. So that will be 5.6. Okay. So this was a formula question. G sine theta upon 1 plus k square. Yeah, you can also use that. If you remember the result, you can use that, yeah. So PPT's question small, all right. Yeah, next one I'll just hope it's fine now. So satellite is launched into a circular orbit of radius r around the Earth. The second satellite is launched into an orbit of radius 1.03 r. So here r is the radius of Earth. The time period of revolution of the second satellite is larger than the first one. So using Kepler's law, we know that the time period is proportional to t square is proportional to r cube. So the larger the radius of the satellite, the greater will be the time period. So the second satellite is at a radius of, not radius, at a distance of 1.03 r from the surface. So if this is the Earth, the first satellite is over here at a distance of r. Okay, so this is also r. So this question is basically an application of this formula itself. So we'll call the time period of this satellite as t2 and the other one as t1. So t2 by t1 the whole square equals the second radius upon the first radius. So the radius from the center of the Earth is 2r, and this radius would be 2.03 r. So this is going to be 2.03 divided by 2 whole cube. Okay. So t2 by t1 the whole square. So I guess we have to use some binomial approximations here. So 2 plus 0.3 is how we are going to write 2.03, and we are going to divide it with 2. So inside we'll have 1 plus 0.03 divided by 2 and this thing raised to the power 3. So this 0.03 by 2 is a very small quantity. So we can use binomial approximations there. So this becomes 1 plus nx approximately. So this will become 0.09 divided by 2, 1 plus nx. Actually, we should have taken this square root as well. So this would become 1 plus 0.03 divided by 2 times 3 by 2. So this is the extra part, right? What is this? 3 3s are 9. Time period is larger than. So T2 by T1 is equal to, so 1 plus this will be what, 2.25 divided by 100. Okay. Circular orbit of, okay, this was, okay, I think this was R. Instead of 2R, I think the radius of the circular orbit was R. Right? 2.25. No, I think it's not 2.25. The answer is not 2.25. The answer will be, yeah, I think the issue was the radius of the orbit. The radius of the orbit was given to be R. So the first satellite is over here. The second satellite is over here at 1.03 R. I think that was the issue. Okay, so there won't be a 2 here maybe. So this would be 1.03 and whole cube. So over here, T2 by T1 will be raised to power 3 by 2. And here we'll have 1 plus 0.03 times 3 by 2. This will be 1 plus nx. And this is going to be 9 by 2, 4.5. So 1.45. So this is 1.45 times the second orbit's time period is 1.45 times the first time period. So it is longer by not 1.45, 1.045. Yeah, 1.045. So it is larger by 4.5%. Okay, so yeah, actually the circular orbit was R. I thought it was the distance from the surface of the Earth. Okay, but they have mentioned it's the circular orbit. So yeah, it's fine. It'll be 4.5 actually. Okay, so yeah, moving on. So now we have a tube that is filled completely with an ideal liquid of mass 2m. Mass of the liquid is 2m and it's closed at both ends. The tube is rotated uniformly in a horizontal plane. So we have a tube containing a water and it is being rotated in the horizontal plane. Okay. About one of its ends, if the force exerted by the liquid at the other end is capital F, omega of the tube is. Okay. So we have some sort of a tube like this. This is the axis of the tube and it's being rotated in the horizontal plane with some angular velocity, this tube. Now it has some fluid inside, okay. It is filled with some fluid and while it is rotating you can think of it like the centrifugal force will push the fluid outwards and because of that the fluid will exert a force F on the outer wall of the tube. That F is what we are being asked, okay. So there are different ways to do this, but the best way is to take the fluid as the system, okay. So if I choose just the fluid, the cylindrical fluid as my system, It will look something like this. So I'm drawing it over here. I'm taking this fluid, cylindrical fluid as my system. So as I'm choosing this as my system, if the fluid exerts a force F on this wall of the tube, then the wall will exert a force F back on the fluid. Okay, so that F force will be exerted back on this fluid at this location. So I hope that is clear. This is just Newton's third law. Okay, so now the thing is, this is the only external force other than mg and normal, but mg and normal is not important to us. We are only interested in finding out, we are only interested in the horizontal plane motion. Okay, so this force F, if I look at it from the top view, if I look at it from the axis, okay, and if I look at the fluid body, let's say this is the axis. This will be the fluid body. We have a force F acting along the radial direction, and this fluid body is rotating with some angular velocity, right? This is the view from the top view. Now the question, now the thing is, because this fluid body is rotating, we can use Newton's second law, okay, which is F net equal to mass times the acceleration of the center of mass. So where is the center of mass of this fluid body? It is exactly at the middle, right, because it's uniformly distributed. So the radius, the tube length is 1 meter. So let's call it as L. So this distance is L by 2. So the distance of the center of mass is L by 2. What is the acceleration of the center of mass? So center of mass is moving in a circle of radius L by 2. So which means the acceleration of the center of mass, you can either write it as omega square L by 2 or V square by R. So I'm using omega square L by 2. Omega square R, because it's moving in a circle of radius L by 2. So now we will use F net equal to mass times the acceleration of the center of mass. So net force is this only force F. So F equals mass of the fluid. Okay, mass of the fluid was in fact given to be 2m. So we'll use 2m times the acceleration of the center of mass, which is omega square L by 2. So from here, omega square turns out to be F divided by ml. F divided by ml. L was given to be 1. L was given to be 1. So this alpha, this constant, will be 1. Okay, so I hope that is clear. Can we use F L equals L alpha? Oh, I alpha. Okay. F into L equals no, F is not in this direction, right? Right, F, it's not a tangential force, it's a radial force, right? F is like kind of compressing this fluid. So the torque, if you calculate it anyway, it will be F into, I mean the force passes through the origin. Thank you, sir. Support from Tamil Nadu. Yeah, thank you so much. Sir, can you, yeah, the PDF will be shared in the WhatsApp group. I'll ask them, okay? So moving on, hope this question is clear. The other method was to, integrate the centrifugal force. So we take an element at some distance of dx, okay, of width dx at a distance x, and the centrifugal force will be dm omega square x, which will be pushing it to the right, and then we integrate it throughout. Okay, so the integration will make it lengthy. So this way it is easier. So amount of work done to break a big water drop of radius r, radius capital R, into 27 drops of equal radius is 10 joules. The work done required to break the same big drop into 64 drops of equal radius will be. Okay, so this is the surface energy formula. So work done to break a big water drop of radius r. So what is the surface area of this drop of radius r? So the surface energy, we can write it as the surface area 4 pi r square times the surface tension, right? The surface tension, let's take it as T. This is the initial surface energy. Finally we break it into 27 small drops of equal radius. So we break that R radius sphere into 27 tiny drops, right? So we'll use volume conservation to find out how many drops are there. No, how many is given, but the radius of the small drop. So the volume of the larger sphere was 4 by 3 pi r cube, and this will be equal to, we have 27 tiny drops. This was made into 27 tiny drops, and tiny drop volume is 4 by 3 pi small r cube. Okay, using this equation we can find small r. It will be capital R divided by 3. So the small drops have 1/3 the radius of the large drop. Now, which means now we can easily write the final surface energy. It will be, we have 27 drops, 27 surface areas. So surface area will be 4 pi small r square multiplied with the surface tension. Okay, this is the final surface energy. This is the initial surface energy. Delta will give us the work that needs to be done to convert them. Okay, if you choose the difference of this. So I'm not doing the calculation. Now in the second step, we break the big drops into 64. Now if you break it into 64, the new radius will be r by 4. So the calculation remains the same. Okay, so yeah, this is a straightforward question, I guess. It's just change in surface energy, that will be the work done. Okay, work required. All right. So yeah, I'll give you guys the answer. The answer is the first option. You guys can do the calculations and recheck it. Okay. All right. So now we have small rigid spherical ball of mass capital M. It is dropped in a long vertical tube containing glycerine. The velocity of the ball becomes constant. Okay, this is because the viscosity of the fluid, it will come to a constant velocity, which we call it as the terminal velocity, right? And this happens after some time. If the density of glycerine is half the density of the ball, density of the liquid is rho by 2, rho of the ball is rho, then the viscous force acting on the ball will be. Okay, so let's draw a diagram first. So if the ball is over here, we have the weight of the ball, it will be mg. Then we'll have the buoyancy force acting. Because the density of the fluid is half the density of the ball, buoyancy is proportional to density of the fluid, right? So this will be mg by 2. Right, it will simply be rho Vg, but the rho of the liquid is rho by 2, the rho of the ball by 2. So the buoyant force will be mg by 2. And then we have the friction. Yeah, so now we know that the ball comes to constant velocity. Now velocity constant, this just implies zero acceleration, right? So net force on the ball is 0. So the viscous force, if I call it as F, this F plus mg by 2 should be equal to mg, which means F should be mg by 2. Okay. Hi Ayush. So yeah, this question was easy. It's just a simple FBD balance. Like we don't need that formula, the scary formula of the viscous force. Okay. So that is it. Moving on. Light hollow cube of side length 10 centimeter and mass 10 gram is floating in water. Okay. It is pushed down and released to execute SHM. The time period of oscillations is what we have to find. Density of water is 1000, G is 10. Okay, so the cube is first of all floating underwater. So 10 centimeter cube. So it's not completely submerged, it's partially submerged. Underwater like this. So now the thing is, when it is submerged, let's say this distance is y and the base area is A. So the volume submerged is A times y. So rho times submerged, rho of the liquid times submerged volume times G will give us the buoyant force, right? that will be equal to mg of the cube. So right now at the start, when we don't push, the cube is in equilibrium. So this mg force will be balanced out by the buoyant force. This is the first part, which is what is given to us. So now what we'll do is we'll push the cube inwards by a small amount, okay, and then we release it. Now when we push the block inside, so let's remove this. So right now the block is in equilibrium. Now what happens when we push it inwards? So let's say we push the block by a small distance of x. Okay, so the upper level will come down by x and the bottom level will go down by x. So this bottom face of the cube goes down by a distance of x. So there is some additional volume submerged. Okay. Now this additional submerged volume will generate an additional buoyant force upwards, and now which means we will have a net upward force. Why a net upward force? Because just by this part's buoyant force, we will have, that part which was the already submerged volume, that buoyancy balanced out mg. Now we pushed it down by a little bit more, so this creates additional submerged volume, and this additional force created by that submerged volume, which is the additional buoyant force, will push the block upwards. So now we'll have a net upward force if we push it down by x. We need to find out this net upward force. Now this net upward force will of course just be the volume submerged extra, the extra volume that was submerged, which is this part. Okay, so we pushed the block down by x, so this distance is x. The base area of the cube is, let's say, a. So the submerged volume is a into x, submerged volume, density of the liquid, so this is water, so density of the liquid into g. Now we took the positive x direction to be downwards, okay, so we'll put a negative sign here because the net force is opposite to the displacement, okay. F net, we can write it as mass times the acceleration, because now the block will accelerate. Initially it was in equilibrium, but once we push it in, there will be a net force, and if there is a net force, there is a net acceleration. So we will write the F net as ma. This will be equal to minus a density of liquid into g times x. Okay, and now we can easily see this is an SHM. So we take the mass over here. So mass of the block, we can write it as density of the block times area of the block times the side length. So this is a cube, so side length I am taking it as a. So a cancels out. So the acceleration comes out to be minus rho w upon rho g divided by a times x. Okay, so now I guess everything else is given. So density of the liquid is 1000, g is 10. Now we don't know density of the object. So density of the object, what we can do is we have mass given to us, divide it with the volume, and with that we can find the density of the object. Or basically instead of rho a, we can just put m here. And the side length we will use the symbol L because A is already used. So anyways, now it's just calculation, right? So A, when you write it as minus omega square x, the time period is simply 2 pi by omega. This is the simple SHM logic, right? So I'm not doing the calculations. The main step is to write down the net force and figure out the net acceleration. Alright, so the answer will come out to be 2 once you solve it. Okay. Alright, moving on. Closed organ and an open organ tube are filled by two different gases having the same bulk modulus, but their densities are different, rho 1 and rho 2. So the rho 1 gas is filled in a closed organ tube and the rho 2 gas is filled in an open organ tube. The frequency of the 9th harmonic of closed tube is identical with the 4th harmonic of the open tube. Length of the closed tube is given as 10 centimeters and the density ratios are also given. Then the length of the open tube is, okay. So this is, let's say, the closed organ tube. Okay, this end is open. So the fundamental frequency, or the fundamental, in order to find the fundamental frequency, the standing wave pattern will be like this for the closed organ tube. So here the thing is, the length of the tube, if it is L, the distance between one antinode and a node is actually lambda by 2. So length will be equal to lambda by 2. Okay. Now we can write the speed of the disturbance equals f lambda. So fundamental frequency times now lambda by 2 is equal to L. No, actually this will be lambda by, yeah, this will be lambda by 4, I guess. Yeah, this will be lambda by 4, my bad. This will be lambda by 4. So length of the tube is lambda by 4. Okay, so lambda will be 4L. So speed of disturbance equals frequency times the wavelength. So this will become 4L. And from here the fundamental frequency turns out to be V divided by 4L. Okay. Now we wanted the ninth harmonic. So ninth harmonic is 9 times the fundamental frequency. So in the first case, F1, the ninth harmonic frequency will be 9V1 divided by 4L. Okay, now for the open tube, the only difference is that at both ends we'll have antinodes. Okay, so the situation will be something like this. Okay, so here this is lambda by 4 and this is lambda by 4, so totally it is lambda by 2, right? No, antinode to node is lambda by 4, antinode to node is lambda by 4, so totally it is lambda by 2. And this length, okay, so the lengths are also different. So we'll call this as L1 and this will be L2, let's say. So here the fundamental frequency will be V2 divided by 2L, 2L2. Okay, this is the case for the open tube. For the open tube, both of the endpoints will be antinodes. Okay, so now fourth harmonic of the open tube. So basically this multiplied with 4 is the fourth harmonic. So 4V2 divided by 2L2. Okay, so these are identical is what they have given over here. Ninth harmonic of the closed tube equals fourth harmonic of the open tube. So now this is the length of the closed tube, length of closed. Okay, and L2 is the length of the open tube. That is what we have to find. Now V1 and V2 you guys can find it. Bulk modulus and density is given. So the velocity you can find it as square root of B by rho. Okay, V1 will be square root B by rho 1. V2 will be square root B by rho 2, and after that once you get V1 by V2 you can easily find out L2. Okay. Direct formula for question 17. You mean like you know the formula for the fundamental frequency and you just want to apply it? Yeah, of course you can do that. I was just explaining the method over here. So the speed is B by rho. You should remember this actually. The length of the tube is lambda by 4. Fundamental frequency, we quickly write it as V by 4L. And once we know the fundamental frequency, the nth harmonic will be n times the fundamental frequency. And once we write the fundamental frequency of the closed, which is the ninth one, right? Ninth harmonic of the closed tube equals fourth harmonic of this, and we equate that. V1 by V2 we can find it, it will be root of rho 2 by rho 1. Okay, and after that it's done. All right. Next question. So the amount of ice is given of mass 10 to the power minus 3 mass of ice. Initial temperature is minus 10 degrees Celsius. So we have minus 10 degrees Celsius ice, and it is transformed to vapor of 110 degrees Celsius. Okay. So by applying heat, the total amount of work required for this conversion is, so how much energy do we need to supply for taking minus 10 degree ice to steam? Specific heat of ice, specific heat of water, specific heat of steam, everything is given basically. So I mean, I'll just explain the process here. This is a standard problem. So first we'll convert the minus 10 degree ice to 0 degree ice, right? And for this we will need to supply an M specific heat of ice delta T, right? And then we take this 0 degree ice and convert it into 0 degree water, the phase change process, okay? Ice to liquid. And for this we will need to supply latent heat of fusion times mass. So mass of ice times latent heat of fusion. This is the second heat needed. Now we convert 0 degree water to 100 degree water, and for this we need M specific heat of water delta T, and finally we convert 100 degree water into steam by providing mass times latent heat of steam. So yeah, I mean, this is a calculation problem, so there is nothing much here. You guys can solve it. The answer will be first option. Okay, so yeah, moving on. Gun fires a lead bullet of temperature 300 Kelvin. This is the initial temperature, into a wooden block. The bullet, having melting temperature of 600 Kelvin, penetrates into the block and melts. Okay, so its melting temperature is 600 Kelvin, which means the bullet heated up. It reached 600 Kelvin and then it melted. If the total heat required for this process is 625 joules, then the mass of the bullet is, okay, so basically if we have a 300, this initially the bullet's temperature was 300 Kelvin, right? Then what happened was it penetrated into a wooden board, and it's given in the problem that the bullet melted. So what does that mean? The melting point is 600 Kelvin. So the temperature of the bullet, it went from 300 Kelvin to 600 Kelvin first, and once again this requires a mass specific heat into delta T, right? Specific heat of heat capacity of lead is given, that into mass into delta T. Delta T will be 300 Kelvin. This is the heat required to convert it into 600 Kelvin, and after this process we do melting, right? After this point the phase change happens, and for this we need latent heat of fusion of lead times the mass, ml. So ml plus ms delta T is the total amount of energy that is needed for the lead to melt. So that will be the answer, and that total is given to be 625. So 625 will be ms delta T plus ml. Okay, so you can solve for the mass after this. S is given, L is given, delta T is also no. You can solve for the mass and the answer will be 1. Okay. All right. So this is a heat transfer question, conduction heat transfer. So we have 3 conductors. Thermal conductivity is K1, K2 and K3. Okay. Connected as shown. Area of cross sections of the first and second conductors are same. So these two have the same area of cross section. This guy has double the area. The temperatures are given in the figure. The steady state condition, at the steady state condition the value of theta is. So steady state means at each and every point the temperature is constant. One steady state is achieved. So this theta is what we have to find. So what is given to us is K1 is 60, K2 is 120 and K3 is 135. Now because this is not a calculation type problem, what we can do is, these are all multiples of 15, right? So this is, so what I'm going to do is I'm going to say K is equal to some 15. Okay. So this K1 will be 4K K2 will be 8K and K3 will be 9K. Okay, this is to eliminate, like once we can easily take the ratio if we write it this way. Now what we can do is we can find the individual thermal resistances, right? Of one, the conductor 1's thermal resistance will be the length of the conductor. So are any information about the length given? Yes, they have the same length. So L divided by K1 is 4K, 4K into area of cross section. So let's say these two have areas A. So the third one will have area 2A. So this will be L by 4Ka. Thermal resistance of conductor 2, this will be the length L divided by K2 is 8K. So 8K into A. And thermal resistance of conductor 3 will be L divided by 9K but into 2A, because conductor 3 has a twice the amount of area. So this will be L by 18Ka. Okay, so now once we have the thermal resistances, this we can convert it into a Ohm's law problem, basically a circuit problem. So at the left end we have 100 degrees Celsius, so that we can treat it as a 100 volt terminal or node. Okay, so this point we can treat it as like a 100 volt point, and then we connect two resistances, thermal resistance 1, thermal resistance 2. They are in parallel. Why are they in parallel? Because the potential difference is the same. Temperature difference is 100 minus theta for both the conductors. So they are in parallel, and at this node the temperature is theta, so we'll take it as theta volt, okay, which is this node. And then we have a third resistance over here, which is R3, and this point is at zero potential. So now it's a Ohm's law problem, right? What we have to find is theta. So you can just equate the current. So this equivalent resistance will be R1 R2 by R1 plus R2. So let's call it R equivalent. So now the circuit is 100 volt. We have the R equivalent, and we have R3. This point is at theta, this point is at 0. So now the thing is these two are in series, so the current is same, right? So what is the current through Re? 100 minus theta divided by Re, right? That should be equal to theta minus 0 divided by R3. So 100 minus theta divided by Re equals theta minus 0 divided by R3. So from here we can get theta. Now what is Re? Re is R1 R2 by R1 plus R2, the parallel series combination formula. And we calculated R1 R2 R3 here. So the L and Ka will get cancelled out. So that's why I said this is not a calculation problem. I mean, we don't have to individually substitute L, K and A. Okay, so now all that is left is calculations, and the final answer will come out to be 40 degrees Celsius. Okay. Can we use Q by T equals Ka dt by, yeah, that's basically what we are using. But here the thing is, instead of like the formula you mentioned, the heat current we are comparing it with I, the current equals Ka delta T by delta X, and this delta X, the length of the rod, we take it as L, Ka we take it to the denominator, we call that as the thermal resistance, and then it will become like the Ohm's law type. I mean that's what we did, but yeah, it's the main idea is we have to convert these thermal resistance L by Ka and then once we get that, we can use Ohm's law to find it. Instead of temperatures, we can convert that into potentials, right? Like once we know the potentials, like this node has a potential of 100, this node has a potential of theta, this node has 0. So what is the potential difference in this resistor? It will be 100 minus theta divided by the resistance. It will give us the current, right? This same current passes through this R3 as well, which means, and the current through R3 we can find it as theta minus 0 potential difference divided by R3. All right, moving on. So two spherical bodies, same materials, have radii 0.2 and 0.8. They are placed in the same atmosphere. Temperature of the smaller body is 800. Temperature of the bigger body is 400. So we can use symbols for this first. So the first body is radii, we'll call it as R, and the temperature as T. Okay, this is the first body. Second body is radius is 4 times as much, 4R, and the temperature is half, which is T by 2. If the energy radiated from the smaller body, so we are talking about black body radiations here. So energy radiated by the smaller body is E, the energy radiated from the bigger body is. Assume effect of surrounding temperature is to be negligible. Okay, so this is a sphere whose radius is R and the surface is at temperature T. So this body will emit radiation. Any body at temperature greater than 0 Kelvin will emit thermal radiation. And this thermal radiation, the power we know that heat transfer rate, the Q dot just means dQ by dt. Okay, this is the power of the radiation emitted equals sigma A T to the power 4. Okay, so that is the radiation emitted by this body. So essentially the game is between A and T because the energy they have given and we have to compare energy. Okay, so this is the rate at which energy flows out of the body. So I'm going to call this as Q dot. Okay, Q dot is the same as dQ by dt. So we have to compare their energies, right? First body's energy they have given as E. So E divided by E2 is what we have to find. So it's basically sigma is a constant, game is between A and T. So first guy's area will be 4 pi r square and temperature is T, so T to the power 4. Second guy's area will be 4 pi into 4 r the whole square. So 4 pi times 16 r square basically. But the temperature is half. So half to the power 4 will be 1 by 16. Right, so T to the power 4 divided by 16. So if you observe, this 16 cancels out with this, right, which means the numerator and the denominator is the same, or basically E equals E2. So because the surface area is 4 times, the radius is 4 times, surface area is 16 times, but because it's half the temperature, that T to the power 4 term makes it T to the power 4 by 16, they both cancel and effectively they both emit the same amount of radiation. Okay, so the answer is going to be E itself. Okay. All right. A cup of coffee cools from 90 to 80 in T minutes. When the room temperature is 20 degrees Celsius, the time taken by the similar cup of coffee to cool from 80 to 60 would be at the same room temperature. So this is the question from the average form of Newton's law of cooling, right? So Newton's law of cooling, that's what we'll be applying here. So in the first case, so the formula is delta T divided by delta T, or let's just call it as T, equals minus K times T average minus T surroundings. Alright, so this is the formula. This is the average form of Newton's law of cooling. So here the thing is, in the first case, the cooling is from 90 to 80, right? So instead of writing delta T equals -10, we can get rid of this minus and write delta T as 10. The time it took was T minutes. This would be equal to K times T average. So average of 90 and 80, 85, minus T surroundings. We don't know the surrounding temperature, right? So we'll just write it as T surroundings. Okay, room temperature is given, it is 20. So 80 minus 20 will be 65. And in the second equation, the delta T is 80 to 60. So delta T is 20 divided by the new time, we will write it as T dash equals K times. What is the average of 60 and 80? It will be 70. And minus the room temperature 20. So this would become 50. And now we'll just divide them, right? So we'll get T dash divided by T into 2 is equal to 65 by 50. This is 25, 13 and 5. So T dash is 13 T divided by 5. Fourth option. Okay. So the average form of Newton's law of cooling. Yeah, actually the brightness, I can probably turn off this light. Is that fine now? Okay, so an ideal gas goes from initial state to final state. During the process, the pressure of the gas increases linearly with temperature. Pressure increases linearly with temperature means pressure equals kT. K is a constant. Pressure proportional to temperature. So this means, you know, using ideal gas relation, PV equals nRT. So pressure proportional to temperature means the volume of the gas is a constant in this process, right? Volume constant implies this is an isochoric process. So the process is isochoric, that is correct. E option is correct. The internal energy of the gas is increased. So internal energy of the gas is simply a function of the temperature, okay? So if the temperature increases, the linear internal energy will also increase. So this is also correct. The volume of the gas is increased is wrong. Heat added to the gas is different from change in internal energy. Now because this is a isochoric process, if I use the first law, which is Q equals delta U plus work, work is 0. Why is the work done 0? Because the gas can't displace, right? The volume of the process is constant. So work is essentially the integral of P dV. So if there is no displacement of the gas, there won't be any work done. So this is 0, which means the internal energy change is the same as the heat given. So if you heat the gas, it directly goes to the change in internal energy. So the heat added is different from the internal energy increase is wrong. So B is also wrong. Okay, so work done by the gas during the process is 0 is correct, because in an isochoric process the work done is 0. So A, D and E is correct. Okay. All right. So PV diagram is given, we have to find the work done. So this is the diagram, I will draw it using a different color, A, B, then B to C, then C to D. Okay, this is the process given to us. We have to calculate the work done. So work done and PV graph, if I have to calculate the work from A, B, C to like this point, that work is simply this area, this square, not square but rectangle. Okay, that is the work from A to B, B to C and C to this point. Let's call this point as X. Why is it? Because A to B is A to B work done is going to be this area, B to C work done is 0 because isochoric, and from here to here the work done is going to be the area underneath that, this area. Okay, but this yellow work done is negative and this red work done is positive. So ultimately the net work done will be just this area. Okay, and because the compression process from C to X is the dominant one, because this is above the expansion process, effectively the work done will be negative, right? Negative compression work is negative. So which means this yellow area, and also we have this process from X to D. Okay, and what is the work in this process? It's the area under this process, which is going to be this yellow area, this whole rectangle. So this yellow rectangle and this yellow rectangle, that is the answer. Okay, so let's calculate that. So the area of this part is going to be, the base is V0, base length is V0, and the height is going to be P0. So just P0 V0, but because the compression process is the dominant one, it will be negative. So minus P0 V0, and the area of this part, so height is 2 P0 and width is V0. So the area of this work is going to be 2 P0 V0, but this is also going to be negative because this is a compression process. So minus 2 P0 V0. So the net work done is minus 3 P0 V0. Okay, so option 3 will be the answer. Okay, it won't be minus 4. I think you included this area as well. That won't be included. Okay, because if only C to X, if you consider only the C to X compression process, then the area will be that full rectangle below it. Okay, this will be minus 2 P0 work, but the thing is there is this AB work. Okay, the AB work is a positive work because it's a expansion process. So this positive P0 V0 minus the negative 2 P0 V0. So ultimately it will be minus P0 V0. Okay, on that part, on this part. Okay, so that is it for this question. So we have another process. We have to find the magnitude of heat exchanged. Q is what we have to find. A, B, C, A to B, B to C, and C to A. So the first thing is, this is a counterclockwise sense process. So we also saw in the last lecture that whenever we have a counterclockwise process like this, the net work done is negative. Okay, we have to find the magnitude of heat exchanged. So Q is just a simple application of first law. Q equals delta U plus work. Delta U will be 0 because this is a cyclic process, right? So we are starting from A, and at A, let's say the internal energy is UA. We are going and completing a cycle and coming back. So delta U is 0 because it is a state function. So initial state and final state is the same, so delta U is 0. So we needed the Q, which is simply going to be the work done. Okay, so work done, if we have the PV graph, is simply the area. This is a semicircle. So the area of this semicircle is the answer. So the height of this So if you observe, this is the diameter of the circle, which is 200 kilopascals. So the radius of the circle is 100 kilopascals, right? Or 100 basically. Yes, radius is 100. Yeah, radius is 100 units. So what we can do is, radius of this circle is, so this is 400, this is 200, so this would be 100. Yeah, so pi r square by 2. So the area is pi times 100 square divided by 2. But this is in, because this is in kilopascals, and the volume is in cc, centimeter cube. So we have to do some conversion. So this will be kilopascals, centimeter cube. Pressure into volume. So this will be pi by 2 times 10 to the power 4. Kilopascals would make it 10 cube. 10 cube pascals. Centimeter, if you convert it into meter, this will give a 10 to the power minus 6. And now it will be in scalar, I mean SI units, Pascal meter cube. So 7 minus 6 is 1. So the answer will be 5 pi. Okay, so I guess option A is going to be the answer. Okay. So yeah, this we had to convert the units. So the pressure units is kilopascals, volume units is cc, cc is centimeter cube. So we have to convert it into SI units as well. Kilopascal, we'll multiply it with 1000, centimeter cube to meter cube multiplied with 10 to the power minus 6. So minus 6 plus 7, 10, 10 by 2, 5. 5 pi will be the answer. Okay. A polyatomic molecule CvCp is given, goes from phase space point A. Point A's pressure and volume are given, point B's pressure and volume are given. Similarly, point C is also given. A to B is an adiabatic path. So this process is an adiabatic process, A to B. And from B to C, it is an isothermal path. So from here to here, this is an isothermal process. The question is, what is the net heat absorbed per unit mole, so for 1 mole, by the system? So heat absorbed, okay, firstly A to B is an adiabatic process, so QAB is just 0, right? So A to B is basically useless to us. So we just need to focus on B to C, which is the isothermal process. And the thing is, this process B to C, it's part of this isotherm, right? And isothermal process means the same temperature, which means the temperature for this process is constant 450 Kelvin. So the process from B to C will have constant temperature of 450. Okay. Now the question is, what is the net heat? So Q BC equals W BC plus delta U BC. Now delta U is a function of temperature and the temperature is constant. So this will become 0. There is no change in internal energy. The work done in an isothermal process, if you guys remember the formula, it is nRT ln V final upon V initial. Okay. So we wanted the answer for per unit mole. So N is 1. Temperature is 450 Kelvin. Final volume is Vc. Initial volume is Vb. Vc is 8 times 10 to the power minus 6. Vb is 6 times 10 to the power minus 6. So Vc divided by Vb will be 4 by 3. So ln of 4 by 3. So this will be the answer. Okay, 450 R ln 4 minus ln 3. Second option. Okay. So the work done in an isothermal process is what we use, is what we needed in the question. Okay, the adiabatic process, there won't be any heat transfer, right? That is the definition of that process. dq is 0. So that A to B path is basically useless if we want to calculate the heat. Heat transfer will only be in B to C, which is the isothermal path. And for isothermal process, the heat transfer is the same as the work done, because there is no change in internal energy. Okay, and the work done in isothermal is nRT ln V2 by V1. Okay, and the final volume in the isothermal process is Vc, initial volume is Vb. Okay, and that is it. All right, so now we have a short dipole that is placed at the origin. The dipole moment P is along the x-axis. Okay, so this is the dipole, point dipole. If the electric potential and electric field at A is this point on the axis of the dipole, it's given as V0 and E0. Electric potential and electric field is given. Then the correct combination of the electric potential and electric field at point B. So we have to compare what is the electric field and potential at this location to the electric field and potential at this location. So this is the formula based problem. So on the axis of a dipole, which is this point, the electric field is simply 2 kp by distance cubed, and the potential is kp cos theta by r squared, right? So over here it will be cos theta will be 0 and it will be kp by r square. So V0 is kp by r square, and this is the E0 value. E0 and V0 is the electric field and potential at this location. Now at this location B, the electric field will be in this direction and it will be kp divided by distance cubed, but the distance is 2r, so 2r cubed will make it 8r cubed. So this, if you observe, is 1 by 16th of this value, right? So this will be E0 by 16, and the potential at this point is just 0. The potential is going to be 0, right? Cos 90, it will make it 0. So the answer is the potential is 0 and the electric field is E0 by 16. This option, second option. Okay. Next is a flux problem. So we have a square loop whose side is A. Normally it is held normally in front of a point charge Q of 1 coulomb charge. The flux of the electric field through the shaded region. Now this distance of the center of the square sheet from the charge, this distance is A by 2. Okay. Now we have to find the flux through this shaded part. Okay. So so from the normal direction view, which means if you look at it through this line's view, what you will see is a square. Okay. Hence we'll split it. So this is one line. This is the second one. We'll draw the diagonals as well. Okay, so we split this square into 8 sides, 8 parts basically. So the thing is, the point charge is placed above this point. Okay. Now the first thing to understand is that this situation is similar to having a cube, having a cubical surface, right? The cube problem all of you have done, and we place a point charge plus q at the center of this cube. So everybody knows the result, that due to this point charge, the flux through one of the faces will be q by 6 epsilon naught, right? Flux through one face, any one of the faces, it is q by 6 epsilon naught. This situation is exactly identical to this situation. If you ignore all the faces and only choose one face of the cube, so if you only choose like one of the faces of the cube, Then the point charge q is placed at a distance of a by 2 from the center of the square, and the side of the square is a, which is the same as this situation, right? So first of all, if I want the flux through the whole square, so all of these parts are symmetric, right? So the point charge plus q is, you can say, somewhere over here, right, along this pen's axis. So all the 8 parts that you're seeing, they are symmetrically placed with respect to the point charge q. So which means if I say the flux through any of this, any one of this 8 pieces is phi, so flux through any of these 8 pieces is phi, if I say, then what do I have to calculate? This plus this, right? So how many pieces are there? So 4, 5, right? There are 5 pieces. I have to calculate this, 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 and this. Okay. So what is 8 phi? 8 phi is the total flux. That would be q by 6 epsilon naught. But what I need is only 1, 2, 3, 4, 5, 5, 5, right? 5 times phi. So this will be 5 times phi is q divided by 48 epsilon naught. That will give you the answer. Okay, so 8 phi is q by 6 epsilon naught. What we need is 1, 2, 3, 4, 5. Yeah, seems fine. Okay, so q is 1 coulomb. So 5 divided by 48 times q is 1. Oh yeah, so we have to write it in this form. So P is going to be 48. Okay, so the answer is 48. Okay, that was the flux question. So now we have a particle mass m charge q and a. So it's over here and it is released. Equilibrium length L, whose other end is, so this is connected with a string and is attached to this point O. Now the whole system is placed on a frictionless horizontal plane and it is initially at rest. The uniform electric field is switched on. Electric field is along the x-axis. It is switched on. Then the speed of the particle when it crosses the x-axis. So this is a positive charge plus q, right? Electric field is to the right. So once we release this system, there will be a force of QE acting along the x direction. But of course the string is holding this charge in place, so it won't fly off. So it will move in a circular path and it will hit the x-axis at some location over there, right? This is the L length string and it will have some velocity like this. This velocity is what we have to find, okay? Speed is what we have to find. So what are the forces acting on the particle? Tension and electric field. So tension won't do any work, so we can use work energy theorem. So work done by the electric field equals change in kinetic energy of the charge, because the work done by the tension force acting on the particle is 0, because this is circular motion, right? So tension and the speed will always be perpendicular, or tension and instantaneous displacement is always perpendicular. So work done by tension is 0. So work is only being performed by the electric field. Okay, so that is what we have to calculate. So this is the x-axis, this is the string, this is the particle, and finally when the string hits the x-axis, it will look something like this. The particle will be here. Now because this string cannot be broken, the velocity will be in the downward direction. Over here the velocity is 0. Now the thing is, the electric field is along the x direction and it is a uniform electric field, right? It is a uniform electric field. So whenever we have a constant force, its work is very easy to find. It's force dot displacement, the total displacement. So force is along the x direction. So all we have to do is find the x displacement of this particle. So how much did it displace by in the x direction? We'll have to find that. So this length is L, the angle theta was 60 degree. This was 60 degree, okay. So L cos 60, so this distance is L by 2. When the string hits the x-axis, this total length will become L. So L minus L by 2, this displacement along the x direction is simply L by 2, okay. So if I know the force is QE along the x direction and the displacement along the x direction is L by 2, the work done by the electric field is the electric force QE multiplied by the x direction displacement L by 2. So this is QE L by 2, okay. The work, that is the work done by the electric field. All right, and now once we get the work done by the electric field equals the change in kinetic energy, which is half mv square. So v square is, v will be QEL divided by 2m under root. Okay, so that is it for this question. QEL by 2m under root, first option. Wait, it is showing as the second option. Oh wait, I didn't cancel the 2. So it will be QEL by m. Second option. Okay. How much questions? This is question 30. I guess 20 more questions. Match the list problem. So yeah, this we can quickly do it. So electric field inside a uniformly charged spherical shell. So if we have a spherical shell which is uniformly charged, okay, and inside the uniformly charged spherical shell, the electric field everywhere is 0. Okay, this is known to us. So A matches up with 3. A matches with 3. Second is, what is the electric field at a distance small r from a uniformly charged infinite plane sheet with surface charge density sigma? So for the infinite sheet, we know that at a distance the electric field is perpendicular to the sheet and its magnitude is sigma by 2 epsilon naught. Okay, so the second one is B option matches with 2. And C option, the electric field outside a uniformly charged spherical shell with surface charge density sigma. So actually we need it in terms of sigma, right? So if I have a uniformly charged spherical shell of plus sigma charge, at a distance r greater than 0 from a so at some distance r from the center, the electric field is kq by r square, right? So now we just have to substitute all the values. So 1 by 4 pi epsilon naught sigma 4 pi r square, q is sigma 4 pi r square, total charge of the sphere, divided by r square. So this will be sigma by this value. Okay, just have to convert it into form of sigma. Sigma by epsilon naught r square. Yeah, this will be the answer. Sigma by epsilon naught is the epsilon naught. There will also be a capital R square. I think that is missing in the options. Yeah, there will be a capital R square as well. Okay, so that is it. If I have two oppositely charged infinite planes, so if I have a plus sigma and a minus sigma, what is the electric field in between? So due to this plus sigma, it will be sigma by 2 epsilon naught to the right, right? And due to this minus 1 also, it will be to the right, and the net will be sigma by epsilon naught. Okay, all right. Next question. Electric dipole, and it's placed in a uniform electric field. Electric field is along the x direction. Dipole is rotated slightly from its equilibrium position and it's released. What is the time period of oscillation? So this is the x-axis. This is the direction of the electric field, the external electric field, E naught. The equilibrium position of the dipole will be along the x direction itself, right? Because dipole, essentially you can think of it, or you can think in terms of the torque formula, right? The torque acting on a dipole is P cross E. So if P and E are parallel, net torque is 0 and it's in equilibrium. So from this equilibrium position, we rotate the dipole a little bit by a small angle theta. Okay, so I'm zooming in the dipole just to make the diagram easier to understand. So this angle is a very small angular displacement from the equilibrium position x-axis. Now, because of this, there will be a torque acting on the dipole which will bring it back. Because if you do P cross E, so P is in this direction, if you cross it with E, you'll get the direction as into the page. Into the page is x. Okay, so the torque is into the page, which means the dipole will rotate clockwise. So the dipole will come back to the equilibrium position. Okay, and then it will have some velocity and it will go clockwise and it will continue this oscillatory motion. So we have to find the time period of that oscillation. Okay, so now it's also given the electric dipole mass is m and charge is q and length is L. So here the thing is they should have made it clear. So this dipole is something like this. This is modeled this way. Okay, so and of course we have the positive charge here and the negative charge here. This is how it is modeled. So like the positive charge has m, the negative charge has m as well. Yeah, so this is how the dipole is modeled. Okay, so now the thing is it's a mechanics problem because we know the torque. The torque is P cross E, right? Though the magnitude of the torque is going to be PE sine theta. So dipole moment is not given. So that will be just Q into L. Q into L. Electric field is E naught, external electric field. Sine of theta. Now this angle theta is a very small angle. So we'll use a small angle approximation. Sine theta approximately equal to theta. So this will be theta. So this is the restoring torque that is going to bring the dipole back to the equilibrium position, the clockwise torque. So now the torque we can write it as I about the axis times alpha. What is the moment of inertia about this axis? M times L by 2 square. M times L by 2 square. The mass is at L by 2 distance times 2. This multiplied with 2. So this will be ml square by 2. Okay, so moment of inertia is done. So now we can use the torque expression. So torque is I alpha ml square by 2. Alpha equals QL E naught theta naught. QL E naught theta. In fact, we should put a minus as well because angular acceleration and theta are in the opposite direction. Theta is counterclockwise, angular acceleration is clockwise. So from here we get alpha minus QE 2 divided by ml into theta. Okay, so now this is omega square. So 2 pi by omega is the time period, right? So time period will be 2 pi square root ml divided by 2 QE. This will be the answer. Okay. So yeah, this is a mechanics plus the dipole motion problem. So yeah. Okay. Okay, so this is the next problem. We have two capacitors that are connected in parallel to a battery. Charge time graph is shown for the two capacitors. So how much Q varies as time is given for the C1 capacitor and the C2 capacitor. So then the question is, which of the statements is true? We have to compare their energy stored and the capacitance. Okay, so the situation is we have two capacitors, C1 and C2, and they are both connected in parallel to a battery like this. Okay, so the capacitors, the thing is it will have some time while it charges up, and then it will attain its peak value, and similarly the other capacitor will also charge up quick and it will attain its peak value. So by looking at the graph, I can see the peak value charge of Q of capacitor 2 is larger. So if I say this is Q2 and this is Q1, I can see Q2 is greater than Q1 by looking at the graph, because the peak of the second capacitor is higher than the peak of the first capacitor. So what is the maximum charge? The steady state charge, it is CV, Q equals CV, right? So Q2 is bigger, so C2 into V is larger than C1 into V. So from this, C2 is larger than C1, okay? Now the stored energy, the energy stored is half CV square. So even this is proportional to C itself, because the V is the same for both the capacitors as they are in parallel. So U is proportional to C, so which means U2 is larger than U1. Okay, so they are both, so C2 and U2 are both larger than C1 and U1. D option, okay. Next problem. At steady state, the charge on the capacitor, okay. So what exactly is steady state? We have a RC circuit here. So the steady state is when this capacitor is fully charged. Okay, so once the capacitor is fully charged, there won't be any current coming into this branch to charge up the capacitor. So which means the current leaving the battery, it will just follow this path and then come back, okay. So we can use one KVL in this equation. So 5 minus 10i minus 15i equal to 0, which means I is equal to 5 divided by 10 plus 15, 25. So 1 by 5 ampere. This is the current that will be flowing once steady state is achieved, okay. Now I want the charge in this capacitor. So if I want the charge, I want the potential difference across this capacitor, okay. Now this capacitor is in parallel to this resistor. So if I find out the potential difference across this resistor or the potential drop across this resistor, I can find the potential difference between the capacitor plates, right. So the potential drop, this is AB, then we can say VAB equals I into R. So 1 by 5 into 10, which is 2 volts. So potential difference across this capacitor is 2 volt. So charge Q is CV. So 8 times 2, which will be 16 microcoulomb. So 16 is the answer. So here it will be 16. All right. Steady state logic for a capacitor is same. Steady state, in the capacitor branch, the current would be 0. That is the main logic. And the capacitor charge would be constant after that. Next question. Capacitor 6 microfarad is charged to a potential difference of V0 equals 5 volt. So this guy is charged to 5 volt and the battery is then removed and another capacitor C2 is inserted in place of the battery, okay. When the switch S is closed, the charge flows, there will be interflow between the two capacitors until equilibrium condition is reached. What are the charges Q1 and Q2 on the capacitors C1 and C2 when equilibrium condition is reached? Okay, so starting condition is this C1 is charged and it is charged, so C1's capacity is 6, voltage is 5, so 6 5s are 30. So the C1 has a charge of 30 microcoulomb before starting, okay. C2 is uncharged, and now we close this switch, okay. So now what will happen is they will rearrange their charges. So some charge, if I just look at the positive plate and the negative plate, some charge Q will flow from the positive plate to the positive plate of C2. So let's say some Q charge flowed to C2. So this charge will become Q plus Q, and this will be minus Q. Now this positive Q charge flowed from the positive plate of capacitor C1, and initially it had 30 microcoulomb. So this will become 30 minus Q positive, and the negative plate will have negative of this charge. Okay, so this is just charge transfer happening. So here initially we had 30 microcoulomb, Q went away, positive Q went away, and it attached to the second capacitor's positive plate, and because plus Q charge went, here we will have a deficiency which is minus Q. Okay, so this is the new charge and that is the new charge of Q2, C2. Now the thing is, as these two are in parallel, in steady state their potential differences must be same. Okay, potential difference of capacitor C1 across capacitor C1 plate is Q by C, right? So Q equals CV, so delta V is Q divided by C. So 30 minus Q divided by capacitance C1, C1 is 6, equals Q divided by capacitance 2, which is 12. So we cancel this. So Q equals 60 minus 2Q, 3Q equals 60, so Q equals 20 microcoulomb. Okay. Yeah, so we get Q. Now the question is, what is the final charge on C1 and C2? So on C2 it is going to be 20, on C1 it is going to be 30 minus 20, which is 10. So the answer is going to be 10 and 20. So Q1 is 10, Q2 is 20. Okay, so that is it. Yeah, common potential is what we used. Okay, I think you're saying you're talking about this C1 plus C2 into V equals 30. Okay, and you get V equals 30 divided by so C1 plus C2 into V is the final charge, final positive charge, and that will be equal to 30 itself, which is the initial charge, charge conservation. I guess you're talking about that. Yeah, we can use that. Yeah, this is charge conservation itself. Okay, so that is it. Galvanometer, a coil. We have a galvanometer coil having resistance of 30 ohm. It needs 20 milliampere for full scale deflection. So what does that mean? When a current of 20 amperes flows through the galvanometer, it shows full scale deflection. So on the meter, it will be like pointing towards the full scale value, okay, max value. If a maximum current of 3 amperes is to be measured using this galvanometer, then the resistance of the shunt to be added to the galvanometer. Okay, so of course 3 ampere is a huge current, it cannot pass through the galvanometer coil. So if this is the galvanometer, it had a resistance of 30 ohm. Okay, now the max value happens when a current of 20 milliamperes flows through this path. Okay, so when 20 milliamperes passes through the galvanometer, it shows max deflection value. Okay, now we want to measure 3 amperes max to max with this galvanometer. So what we'll do is we'll shunt it using a resistance by attaching it parallel to the galvanometer. Okay, so what this will do is we can send 3 ampere current, okay. So 20 will move to this path and the rest of the current can move through this path. So 3 minus 3 amperes so 20 milliampere would be 0.02 amperes. So 3 minus 0.02 can pass through that particular path. So we have to find out what is this resistance R, okay. So now this resistance R is in parallel with this galvanometer G. The potential difference across these two terminals is going to be the current 20 into 30, right. So 20 milliampere, wait, so this, if we write it as 0.02 amperes times 30, so this will become 0.6. Okay, so 0.6 is equal to 3 minus 0.02 into R. So 2.98 times R. Okay, so that will give you the answer for resistance. So resistance is 30 divided by X. So 6 divided by 29.8. So basically multiply and divide with 5. So I guess this will be the answer. Yeah. So we have to compare it with 30 by X, right? So this will be 30 by X. And this X is equal to approx 149. I mean exactly 149. Okay. Long wire of circular cross section with radius A carries a steady current of I. Current carrying wire. Current I is uniformly distributed on the cross sectional area. So if this is the cross section of the cylinder, the current coming out is uniformly distributed in this area. Okay, so which means if I want the current in some smaller radius, what I can do is that small current I is the total current divided by the total cross sectional area of the cylinder pi r square times the small circle's cross sectional area pi small r square, ratio and proportion. So this will be I small r square by capital R square. If I want the current in a current coming through a small r radius cross section, okay. The question is, what is the plot of the magnetic field B with distance r from the center of the wire? Okay, so first we'll talk about from 0 to A, which is the radius of the cylinder, and what happens after A. So this is just a standard formula. So if this is the cylindrical axis, so the wire is coming out of the page. So I am choosing some Amperian loop whose radius r is less than the radius of the cylinder, okay, inside. So if the current is coming out of the page, which is represented using a dot sign, the current is coming out of the page. So in the Amperian loop, the magnetic field will be counterclockwise by right hand rule. So here the magnetic field will be something like this, counterclockwise. So now we'll apply Ampere's law. So integrating B dot dl on this loop will be equal to enclosed current times mu naught times I enclosed. Okay, so due to symmetry, the magnetic field everywhere will be the same. So B, we can take it out of the integral, and integral of dl for this whole loop, if you integrate, you will get 2 pi r, 2 pi small r. This will be the enclosed current, and this we mentioned earlier, it will be I total current small r square by capital R square times mu naught. So from here we cancel out 1r and we get the magnetic field to be proportional to small r, right? Magnetic field varies directly proportional to r. Now what happens if you choose an Amperian loop outside? The only difference is the B 2 pi r still remains the same, but instead of the enclosed current there won't be a function of r. The enclosed current is the total current I. Okay, so in this case the magnetic field is inversely proportional to r. So we go from direct proportional to r till the radius of the cylinder. So until this point it's direct proportion, after that it's inverse proportion. So straight line to inverse proportion, first graph is the answer. Okay. All right, next question. Okay, this is a magnetism problem. We have to find the magnetic field at O, okay, due to this system. Yeah. So this is a 3/4 of a circle and this is like a semi-infinite wire with respect to this point. This is the semi-infinite wire, 3/4 of a circle. Okay, so we'll do it part by part. So first we have this semi-infinite wire, okay. So the magnetic field due to a semi-infinite wire. So firstly the direction we can use right hand rule, it will be into the page, right. So into the page is x, and the magnitude due to the semi-infinite wire, the magnitude is mu naught I. So it was mu naught I by 4 pi r times sine alpha plus sine beta. So one angle is 0, one angle is infinity, I mean one angle is 90. So it will be mu naught I by 4 pi perpendicular distance d, mu naught I by 4 pi a. This is the magnetic field due to this semi-infinite wire at the point O. Now due to this wire it's going to be 0 because it directly passes through the origin O. So due to this wire it is 0, okay. Now what is left is the circular loop, 3/4 circular loop. Due to the complete circular loop it is mu naught I by 2i, right. Due to the complete circular loop at the point O, the magnetic field is mu naught I by 2r, okay. So due to 3/4 it will be 3/4 basically. So magnetic field due to the other part it is mu naught I by 2a times 3/4 because we have 3/4 of the circle. So this will be 3/8 mu naught I by a. So now it's just a sum of these two because their directions are parallel. So 3/8 and on the other term here we'll have 3/8 and on the other term we'll have a 4. So yeah, second option, okay. Okay. LCR series circuit, resistance value, capacitor value, inductor value are given. The maximum current in the circuit. So in the LCR circuit, the series LCR, yeah, this is the AC one. The current is maximum in the resonance case, right? In resonance situation, the current is maximum, okay. This is because generally the current as a function we write it as V naught divided by V naught. I mean in the total impedance of the circuit when we write it, it is the total impedance is under root of R square plus XC minus XL the whole squared, okay, and this thing under root. This is the total impedance of the series circuit, and for the current we do V divided by impedance, okay. Now current would be maximum when the impedance is minimum, and that happens when XC equals XL, right. So So that is the situation. Current is maximum in the resonance case in which Xc is equal to XL. Inductive reactance equals capacitive reactance. Okay, so now it's just formula substitution. Xc is 1 by C omega, XL is L omega. So omega square equals 1 by LC. Resonance frequency. So omega is what we have to find. It is 1 by square root of L into C. L is 100 millihenry. C is going to be 25 nanofarad, which is minus 9. So 1, 2, this will be minus 1, effectively 10 to the power minus 10. Once you take it out of the root, it will go to the numerator as 10 to the power 5, and there will be a 1 by 5 in the denominator. We need it in power of 10 to the power 4, so this will be 2 times 10 to the power 4 radians per second. So the answer will be 2. Okay, so Xc equals XL, that was the logic. Yeah, 20,000. Next problem is optics problem. We have two light beams that fall on transparent material block at points 1 and 2 with angles theta 1 and theta 2 respectively. Okay, so this is the first light beam. This is the second light beam. After refraction, the beams intersect at point 3, which is exactly on the interface at the other end of the block. So basically, we'll draw a different diagram. So there is this point, okay. We have one light ray coming like this, and then after refraction, it goes and hits this point. And then the second light ray, it approaches like this, and after refraction goes hits the same point. Light ray 1, light ray 2. Now they have given this angle theta 1, it makes with the horizontal, and theta 2, which the other one makes with the horizontal. This refractive index is n1 and the glass slab refractive index is n2. Distance d is also given, 4 root 3. So this particular distance is given, it's 4 root 3 centimeters. Okay, and this angle theta 1 and this angle theta 2 is also given. So theta 1 and theta 2 are cos inverse of n2 by 2n1. So theta 1 equals theta 2 equals cos inverse of n1 by 2n2. Okay, now we need the angle with the vertical because we have to apply Snell's law, right? So we are looking for the angle with the vertical. And what is this angle? This angle is 90 minus theta 1. 90 minus theta 1 is 90 minus cos inverse of n1 by n2, 2n2, which is actually sine inverse, right? So if this angle is alpha, if I call it, this angle is also alpha. Alpha is simply going to be sine inverse of n1 by 2n2. Okay, so now, okay, these two angles are equal also, it's given. So sine, now we can apply, so this is n1, this is n2. So n1 sine alpha equals, so let's say this angle is beta. So this angle will also be beta. n1 sine alpha is going to be n1 divided by 2n2. Okay, this was n2 divided by 2n1. Okay, so this is n2 and this is n1. So this is n2 divided by 2n1. This is equal to n2 sine beta. So sine beta turns out to be half, or beta is 30 degrees. Okay, so we found out this angle beta, it is 30, which means this angle is 60. This angle is also 60. This angle is also 60. This is an equilateral triangle. So if this length is 4 root 3, All the three side lengths are 4 root 3. Okay, so we can find out the altitude, height of this triangle, because that is what we have to find. We had to find the thickness of the block, which is the altitude of this triangle. So this side length is 4 root 3. So this is 60. 4 root 3 sine 60. So h is 4 root 3 sine 60, which is root 3 by 2. So this will be 3 2s are 6 centimeters. Okay, 6 centimeters. All right. Next question. Okay, so we have a thin convex lens of glass, refractive index mu, and each side is having a radius of curvature r. One side is polished for complete reflection. At what distance from the lens the object be placed on the optic axis so that the image gets formed on the object itself? So we want object to be formed exactly at the, image to be formed exactly at the object. So we have a biconvex lens and one side is actually silvered. Okay, you can treat it like a combination of a convex lens and a concave mirror. Now there are two ways to do this. One way is you can write down the equivalent focal length, right, using that power formula, or you can just use mirror formula and lens formula. The thing you need to understand is, let's say if the object is here, first the object will be processed by the biconvex lens, right? So first we will apply lens formula. So 1 by V minus 1 by U equals 1 by F. And 1 by F we can write it in terms of mu and R using the lens maker's formula, right? This will be equal to mu minus 1 times 2 by R, right? This will be the lens maker formula expression for 1 by F. And here we will have 1 by image distance minus 1 by U, object distance. Now the thing is, if I want the image to be retraced, so once the ray is processed by the lens, as it goes and hits the concave mirror, I want it to intercept the concave mirror exactly perpendicular to the mirror at that point. Okay, so basically if this is the concave mirror, and if this is the optical axis, once the ray comes after being processed by the lens, I want the ray to hit the, if this is the center of curvature, this will be the normal, right? I want that ray to hit the mirror perpendicularly. Perpendicularly meaning that ray should be, if you backtrace that ray, it should be coming from the center of curvature. Okay, so basically the ray, after being processed by the lens, it hits the mirror perpendicularly, and when it hits it perpendicularly, it is reflected directly backwards. So whenever we redirect the ray directly backwards, it retraces its original path. So it goes, let's say, in this path, then it comes back in the same path, and the image is formed exactly where the object was. Okay, so that is the logic. So finally, after the lens processes it, the ray should be perpendicularly hitting the concave mirror. Okay, so now the thing is, if the final ray hits the concave mirror perpendicularly, that means the image of the convex lens should form at the center of curvature of this mirror. Okay, so we should in fact be exactly at this point C. So now where exactly is C? C is at a distance of radii of curvature r, right, from the optical axis. So V should be equal to minus r. V should be equal to minus r, minus 1 by object distance. So object distance, I'll just put the negative sign as well, because the object is to the left of the optical axis. This will be equal to mu minus 1 r by 2. I mean 2 by r. Okay. So from here 1 by u turns out to be, so 1 by r, I'll take it to the other side, plus 2 times mu minus 1 divided by r. So we have 2 mu minus 2 plus 1, so 2 mu minus 1 divided by r. So we have the object distance as r divided by 2 mu minus 1. Okay, so this is how you solve it with lens and mirror formula. Yeah, r divided by 2 mu minus 1, yes, fourth option. Okay, so that is it. Spherical surface of radius of curvature r separates air from glass. Glass refractive index is 1.5. Center of curvature is in the glass medium, okay, which means the surface will look something like this. Let's say this is the optical axis. Radius of curvature is in the glass medium, right? So n equals 1.5 here, n equals 1 here. Point object is placed in air on the optical axis on the surface, so that its real image is formed at I inside the glass. So the object is somewhere over here, the image is formed inside the glass. The line OI intersects the spherical surface at P. So this is P. PO equals PI. Okay, so these two distances are equal. So if this distance is x, this distance is also x. The distance PO is equal to, so we have to find x. This is just one application of the spherical surface refraction formula. So image distance is plus x, object distance is minus x. So mu 2 is 1.5 divided by v, v is plus x, minus mu 1 is 1 upon u. U is going to be minus x because it is towards the left, and this is equal to mu 2 minus mu 1, which is 0.5 divided by radius of curvature. Radius of curvature is plus r to the right. Yeah, so plus r to the right. So this will become 1.5 plus 1, so 2.5 divided by x is equal to 0.5 divided by r. This is 5, so x is equal to 5r. Okay, so A option looks like the answer. All right. Yeah, first option is the answer. Yeah, we already did this question. Young's double slit interference experiment is performed using light consisting of 480 nanometer and 600 nanometer to form interference patterns. The least number of bright fringes of the 480 nanometer light that are required for the first coincidence with the bright fringes formed by the 600 nanometer light. Okay, so we want at some point they need to coincide. So how much bright fringes for the 481 is required? So basically the YDSE setup. So let's say this is the screen. So this is the central maxima line. So if I go fringe width beta distance above, we'll get the first maxima. We'll get, if we go another beta distance above, we'll get the second maxima, and so on, right? So what they're asking is least number of the bright fringes of the 480 nanometer light. So let's say that least number of bright fringes, this is the first, second, third, let's say it's the nth bright fringe for the 480 nanometer one. So we would say n times beta of the 480 nanometer one. N times beta would mean we go to the nth maxima, first, second, third, nth maxima. This distance is equal to some, let's say, okay, so this is the 480 nanometer one, right? The 600 nanometer one will have some other beta, right? The beta lengths won't be the same because beta depends on lambda. So the 600 nanometer one, let's say we go up m fringe widths. So we are talking about the mth bright fringe, okay? So the nth bright fringe of the 480, that distance we equate it to the mth bright fringe of the 600 nanometer one. Okay, so now we'll try to find the minimum value of n, which is the minimum number of bright fringe for the 480 nanometer one. So the bright fringe the beta formula, fringe width, is the lambda value, which is 480, capital D divided by slit width. Similarly, on the right hand side it will be small m, 600 into capital D divided by small d. These two cancel out. So small n, we'll get it as 60 divided by 48. 60 is 12 times 5, 48 is 12 times 4 times m. Okay, so we want, so whenever n and m satisfy this equation, these two bright fringes coincide. Okay, so when is the n value minimum? So if I put m is equal to 4, which means m is equal to 4 means the fourth bright fringe of the green line, which is a 600 nanometer one. The fourth bright fringe, if I put m is equal to 4, then 4 cancels out with 4 and we get n is equal to 5, okay, which means the fifth bright fringe of the 480 nanometer line. So this is when they will first coincide and the value of n for that is 5, okay. So the fifth bright fringe for the 480 matches up or coincides with the fourth bright fringe of the 600, and that is the first time they coincide. Okay. Yeah, so the minimum value of m will be 4, but the minimum value of n is 5. They have asked the minimum value of n, minimum number of the bright fringes of 480 nanometer. Okay, and that was n. So n's minimum value, oh yeah, I marked the first option. Yeah, I got it. All right, moving on. So in this diagram, we have an incident ray parallel to the base of the prism. So this is horizontal, this is also horizontal. Emergent ray graces along the second surface. Graces means it moves like this. If you draw a normal, angle of refraction equals 90. That is what gracing means. Refractive index of the material of the prism is √2. Theta of the prism is. So the thing is, when we have gracing emergence like this at some surface, or basically when the angle of emergence is 90 degree, then the angle of incidence, we should draw a new diagram. So let's say this is the prism. So the initial ray is coming horizontal like this. And then after refraction, it, let's say, hits the other surface like that. And after the refraction at that surface, it graces parallel to the surface like this. We'll draw normals at these two surfaces. First normal, second normal. So this angle is 90 degree. Which is the angle of refraction. Now if the angle of refraction here is 90 degree, refractive index of prism is √2, refractive index of air is 1 and the angle, one angle is given 45 degree, the other angle is theta, we need to find theta. So this angle is 45, this angle is theta. So the thing is, if the angle of emergence is 90, then the intercepting angle, this angle theta, this will be the critical angle. So we'll use another symbol. This will be theta c. If light intersects at theta c, then it refracts at 90 degree, right? So what is the critical angle at this surface? It is sine inverse of 1 by root 2, n2 by n1, which is 45 degree. So this angle at which the red light intersects the prism is 45 degree. So this angle is 45. Okay. Now this is of course 90 degree because it's the normal line to the yellow line. So this angle is 90 degree. So in total this angle is 135 degree. Okay. Now this angle is horizontal or basically parallel to the base. So which means this angle is 45, which means even this angle is 45. Okay, so now we can apply the refraction formula at this surface. So this is 1, this is root 2. So n1 sine theta 1, which is sine 45, equals n2 root 2 sine theta, sine alpha, let's say. So from here, this is 1 by root 2, dividing root 2, it will become half. So alpha is 30 degree. So alpha 30 means this angle is 30 degree. Angle of refraction at this surface is 30. This angle is once again 90 degree because normal line to the yellow line. So which means this total angle is 120 degree. This total angle is 120 degree. So now it's just a quadrilateral, right? So 45, 120, 135 and this angle theta. This is a quadrilateral. So summation of all the four angles is 360 degree. So 45, 135 is 180, 180 plus 120 plus theta, this should be 360, right? So this is how much? 300, so theta is 60. Okay. Graces. Yeah, actually that is visible in this diagram. The diagram is not that good, high quality, but it's visible in the diagram anyway. Grazing incidence just means it's parallel to the surface. Okay, that is it. Can't we find the angle of prism first, then use? No, actually, like you have to use these informations, right? You will only find out this angle is 30 using the refraction idea, and you'll only find this angle is 45 using the refraction at the second surface. So you have to find the angles applying Snell's law. Only then you can find theta, right? So that is it for the prism problem. Photoelectric effect, an EM wave is incident on a metal surface and electrons are ejected from the surface. Okay, so work function of the metal is 2.14 electron volt. Stopping potential is 2 volt. So what is the wavelength of the electromagnetic wave? So the stopping potential, E times the stopping potential, this is equal to the kinetic energy of the electron with the maximum kinetic energy, right? E times V stopping equals Kmax. Now what is Kmax? Kmax, the electron with the highest kinetic energy, is having kinetic energy of hc by lambda, which is the energy of the incident photon minus the work function of the metal, right? So E times the stopping potential, which is 2 volt. Hc is given to be 1242 electron volt nanometer. So 1242 electron volt nanometer divided by lambda is what we have to find, minus the work function of the metal, 2.14 electron volt. Okay, so 2 electron volt plus 2.14 is 4.14 electron volts. This is 1242 by lambda electron volt nanometer. So lambda will be 1242 divided by 4.14. That will be 300, I guess, 300 nanometers. Okay. So this is a formula based problem. Okay. Electron in the ground state of the hydrogen atom has the orbital radius of 5.3 into 10 to the power minus 11, while that for the electron in the third excited state. So this is the n equal to 4 radius, right? The ratio of the de Broglie wavelengths of electron in the excited state to that in the ground state. So the radius of the nth orbit, we can write it as a naught n square by z, right, for the hydrogen atom. Here a naught is basically this distance which they have given. It's in the ground state configuration. So for hydrogen it will be simply a naught n square, right? So if you put n equal to 1, you will get the ground state radius, which is a naught, which is what is given here. So in the third excited state is n equal to 4. Okay, so that at that point it will be 16 times, even though it is given. The ratio of the de Broglie wavelength of the electron in the excited state to that in the ground state. So for de Broglie wavelength, we need the mv, momentum, right? Lambda is h over mv. So for momentum, we can use the Bohr quantization rule, angular momentum quantization rule, which is mvr equals nh divided by 2 pi. Okay, and the reason for using this is there is mv here. So the momentum is directly proportional to n divided by r. Okay, and lambda is inversely proportional to the momentum. Lambda is inversely proportional to momentum. Momentum is directly proportional to n divided by r. So which means lambda, which is what we need to compare, is directly proportional to r divided by n. Okay, so lambda of the excited state divided by lambda of the ground state is what is asked, is equal to radius of the excited state. So that is 16 times a naught, right? Divided by n of the excited state, which is 4. And for the ground state, radius is a naught and n is equal to 1. So a naught cancels out with this a naught, 4 cancels out with the 16. The answer is 4. Okay. All right. Electron of mass m with initial velocity v naught I cap enters an electric field of E naught k cap. Okay, so velocity is along the I cap direction, x direction. but electric field is along the k cap direction, z direction. Okay. If the initial de Broglie wavelength is lambda naught, the value after time t would be. So the de Broglie wavelength is simply the Planck's constant divided by momentum, h divided by mv. So we just have to find the velocity after time t. That will give us the answer. So initial velocity is v naught. Initial velocity is v naught. The force on the particle is constant. It is q e naught along the z direction. So we can easily write the velocity vector. It will be v naught I cap, because there is no force along the x direction. It will be constant. And along the y direction, the acceleration is q e naught divided by m. So q e naught by m into t, acceleration into t along the k cap direction. So this is the velocity vector as a function of time. Okay. So here we'll have to substitute the speed. So the speed will be, so this is I and k, so square root of v naught square plus q e naught by m into t, the whole squared. Okay, so now we'll just have to substitute this v over here. That will give you the answer. So yeah, they have included lambda naught as well. So lambda naught is nothing but h divided by m v naught. Okay, so basically we can take v naught common from here. So then lambda will come out to be lambda naught divided by square root of 1 plus q e naught t divided by m v naught whole square. Right, this is just taking common, nothing else. So I guess the answer is B. No, not B. I guess A option maybe. Yeah, first option. Okay. Okay, so that was this question. Number of spectral lines emitted by atomic hydrogen, that is in the 4th energy level. So 4th energy level is n equal to 4. So we have 4, we have 3, we have 2 and we have 1. So 1, 2, 3, 4. So the question is how many lines are possible? How many jumps are possible, right? So this is simply 4C2. Most of you may be knowing the formula, right? It's a matter. So basically, how many lines can you draw here? So this is another line. This will be another line. The answer is we have to choose any 2 lines among the 4 lines, which is 4C2, right? 12 by 2, 6 is the answer. Okay, or you can just draw the lines as well, but they are the same. Okay. Next, radioactive nucleus N2 has 3 times the decay constant as compared to the decay constant of another radioactive nucleus N1. So decay constant is the lambda, right? N radioactive law, decay law is N equals N naught e to the power minus lambda t. This is how the first order radioactive decay works. Lambda is the decay constant, and it's given that N2 has 3 times the decay constant of N1. So lambda 2 is 3 times lambda 1. Okay, which means N2, so I'm going to call lambda 1 as lambda. Okay, so N2 I can write it as initial number of both the nuclei are the same. So this N naught is the same, e to the power minus 3 lambda t, and for N1 it is going to be N naught e to the power minus lambda t. So this is the law for N2. This is how the N1 will vary in the sample, the number. Now the question is, what is the ratio of N2 to that of N1 after one half-life of N1? So after one half-life of N1, N1's number of nuclei will be cut into half. So initially we had N naught, so finally N1 after T half will have N naught by 2 nuclei. Okay, this is straightforward. That is the definition of T half, right? Now we need to compare, we need to find out what is that time for N2. So T half is ln2 divided by lambda, right? So T half is ln2 log 2 divided by lambda for the N1 guy. Now so now we'll substitute this time into this equation. So N2's new value will be N0 e to the power minus 3 lambda into T. T is ln2 divided by lambda. Lambda cancels out. 3 minus 3 we can take it to the power of ln2, so that will be minus 2 cube. No, 2 to the power minus 3 e to the power ln 2 to the power minus 3. This is my exponent over here, and this is simply 2 to the power minus 3, which is 1 by 8. So the final answer will be N0 divided by 8. So N2's final number of nuclei will be N0 by 8. N1 will have N0 by 2. So if you do N2 by N1, the answer will be 1 by 4. Okay, fourth option. Alright, that's it. Okay. Alright. Next question. Parallel plate capacitor area 16 centimeter square. Separation between the plates is 10 centimeter. It's charged by a DC current. Consider a hypothetical plane surface of area 3.2 centimeter square inside the capacitor and parallel to the plates. At that instant, the current through the circuit is 6 amperes. At that same instant, what is the displacement current through that A0 surface? So basically, if these are the parallel plates, right? So the question is, we have some sort of a area whose area is given to be A0, which is smaller than the plates area. Plates area is 16 and this guy's area is 3.2. So a tiny area is kept parallel to the plane of the plates. So if these are the plates, the plane of the area A0 will be something like this. Okay. So the question is, what is the displacement current through this tiny area A0? So while discussing displacement currents, we discuss one thing. So if this current, okay, this is given to be 6 amperes. Okay. So when computing displacement current, the displacement current through this total area of the parallel plate capacitor, which would be the A area. So ID, the displacement current through the total area of the parallel plate capacitor, this is the same as the conduction current, which is 6 amperes. Okay. So the total displacement current through the A area is 6 amperes, which is the same as the conduction current. Now, which means for through this area A0, we can use ratio and proportions to find it. So the current through A0, the displacement current through A0 will be the total current 6 multiplied by the area ratio, which is A0 divided by A. A0 is 3.2 and A is 16. Okay, so this is 0.2, 1.2 amperes. Okay, 1.2 amperes, they want the answer in milliamperes, so 1200. Okay. All right. Magnetic field of an EM wave is given by this formula, root 3 by 2I plus J by 2. So what direction is this? So if you do tan theta, it will be 1 by root 3. So this is kind of like 30 degrees with the x-axis, right? That is the unit vector written over here. 30 sine omega t minus z by c. So this is the x-axis and this is the y-axis. So this electric field's direction is root 3 by 2 I plus half j. That is the unit vector along the 30-degree line. So let's draw a 30-degree line to the x-axis. (30° unit vector is what is this written over here? 1 cos 30 is root 3 by 2, 1 sin 30 is half. Okay. So the the magnetic field is actually pointing in this direction. So this is the direction of the magnetic field, B. Okay. And inside we have omega t minus z by c. So this inside term tells us about in which direction the wave is propagating. So inside we have omega t minus z by c. So wave propagation along z direction plus z direction. Okay, if it is omega t minus z by c, wave is propagating along plus z. Okay, so basically the wave propagation direction is out of the page, z direction. So if I want to write that as v cap means the wave is propagating along that direction. It is actually out of the page, which is a dot, right? So that is the wave propagation direction. Now the question is, what is the direction of the electric field? Electric field direction and magnitude. Okay, so first we'll have to talk about the unit vector, right? Let's talk about the direction of the field first. So E cross B, firstly E, B and V are all perpendicular to each other. Okay, so V is out of the page, B is in this direction, and E cross B should give me the direction of V. So E should be in this direction, something like this, such that E cross B will give me the wave propagation direction. So the direction of the electric field will be in a direction like this. I have to make it perpendicular to B and V, okay, something like this. This is the direction of electric field. E and B are also perpendicular, so this angle is 60 degree. Okay. Now if you do E cross B, the direction is coming out of the page, which is the direction of V. Okay, so now we can easily write the unit vector along the electric field's direction. All you have to do is assume a one length in this direction. So if this is the z direction, xy plane, all you have to do is assume a vector whose length is 1, okay, and the angle is 60. Find its components. So it is 1 cos 60 I cap, which is half I cap, and 1 sin 60 minus j cap, which is minus root 3 by 2 j cap. So this is the unit vector of electric field, half I minus root 3 by 2 j, which only matches with first option. And for the magnitude, what you can do is use E equals BC. Okay, so to the magnitude of the magnetic field, just multiply with C. Okay, that's why they have written it as 30C. And the sine term just remains the same. Okay. Okay, sine term remains the same. So that is how we write the electric field in this case, when the magnetic field is at some angle with the x-axis. Okay. All right. Next problem. Okay, diode problem. So we have to answer these statements. So you can think of this like reference voltage as 0. You can take these points having reference potential as 0. Then this point will be at 6 volt. Okay. So clearly this point will have some positive potential, right? So this guy has positive potential, which means the diode is forward biased. Okay, so how to check that? The triangle is basically connected to a higher potential. That's forward biased, right? So the diode is forward biased, which means it will allow the flow of current. So essentially you can just imagine this as a conducting wire itself. So we have 4 and 4 in parallel, so that will become 4 by 2. So a 2 ohm resistance here. Just imagine this like a 2 ohm and ignore the other two. 2 and 4 in series will make it 6 ohm. 6 ohm, 6 volt, current will be 1 ampere. Okay, so the current in ammeter is 1 ampere is correct. Total resistance of the circuit is 6 ohm is correct. Potential across AB. AB is this particular line. So 1 ampere current, when it reaches this junction, it splits into two parts, right? So when 1 ampere reaches this junction, it splits equally because these two resistances are equal. So this becomes 0.5. This 0.5 into 4, I into R, this means the voltage is 2 volt. The potential drop across this resistance is 2 volt. So potential across AB is 4 volt is wrong. Potential across CD, CD is this particular line or a resistor. So if you do 1 ampere into 4, it will be 4 volt. So potential across CD is 4 is correct. So this is of course wrong. So the answer is A, B and D. So first option. Okay. So this was a forward bias question. Next. Okay, so here we have vertical circular motion of a particle. So particle is attached to this thread. The question is if the tension in the thread is 0 at an angle of 30 degree. So we have given it some speed u, let's say. It moves along the circular track, and when it reaches this location, the tension in the thread becomes 0. Then the question is, what is the velocity at the bottom point? Okay, we have to find this u. So firstly, we'll conserve energy between the bottom point and the top point, this particular point. So let's say the velocity at this point is some v. Okay, so this height, this is r sine 30, so r by 2. And this height is of course r. So the increase in gravitational potential energy, the height increase is 3r by 2. So v square by 2, we can write it this way. So half m mu square minus mg into 3r by 2 equals half mv square. Okay, energy conservation. So v square will be u square minus 3gr. Okay, now we just have to make the tension in the string 0 over there. This angle was 30 degree. So the weight force is in this direction. Velocity is in this direction. Okay, so right when the tension becomes 0, so this angle is 60. So mg's component along the radius, this component is mg cos 60, which is mg by 2. This mg by 2 is the only force providing the centripetal acceleration at that location. So mg by 2 is mv square by r. Okay, the speed here is v, so mv square by r. So v square turns out to be rg by 2. Okay, so once we have v square, we can put it here. So u square will be 3 plus half gr. So u will be square root of 7 by 2 gr. Okay, so this is an energy conservation, and tension we have to make it equal to 0. All right. So now we have a wire whose resistance is uniform. So resistance per unit length is uniform. It's bent into a circle of radius r, and another piece of wire with a length of 2r is connected between points A and B. Okay, so they are talking about this wire. This wire has a length of 2r, so r plus r. Then we have this wire and we have this wire. So we have to find the equivalent resistance between A and B. So circle and the two conducting wires. These have lengths r, okay, and this quarter circle's length, circumference length is pi r by 2, and the other part has a length of 3 pi r by 2. Okay, so resistance is proportional to their length. Resistance per unit length was given to be lambda. So if I say this part, this quarter circle's resistance will be this thing multiplied with lambda. This two conducting wires, they are in series, their resistance will be 2r multiplied by lambda. Similarly, the outer parts resistance will be 3 pi r by 2 into lambda. So we have three parallel resistances. Right? If I say this is A and this is B, we have three parallel resistances. So this is 3r and this is kind of like some r. So if I say this is a capital R and this is, then this is going to be 3 capital R. Okay, so if 3 capital R and capital R are in parallel, the equivalent resistance is 3 capital R by 4, right? So we can get rid of two of them, just call it as 3 capital R by 4. The other one is this conducting wire, which is lambda into 2r, so 2r lambda. So now we will just do r1 r2 divided by r1 plus r2. So 3 capital R will substitute it, it is 3 pi r by 2. So 3 pi r by 2 into 3 by 4 times r2 is 2r lambda divided by r1 plus r2. This is 9 by 8 pi r lambda. There is also a lambda. So small r and lambda we can cancel out. 8 we can take LCM. So 16 plus 9 pi. 16 plus, no, this would be 3. Yeah, I mean you guys can check out the calculations, but it should be this, the third option. Okay, it's a simple 3 resistance parallel combination. This is one resistance, this is another resistance, and this is another one. They are in parallel, and their individual resistances you can write it by multiplying the length of that part with lambda. Okay. Done. Next question. So position of a particle is given. So this is a question that appeared in yesterday's exam. X is given. This is a SHM equation. Speed and acceleration, if they become 0 for the first time at t1 and t2, then we need to find t1 and t2. So when does the particle comes to rest first, and when does it come to 0 acceleration first? Okay, so I mean you can just directly write it. So initially it is at x equals a sine 50t plus, so this is the function, x equals a sine 50t plus pi by 3. Okay, so if you put t equal to 0, it will be at some positive displacement. So if this is the mean position where x equal to 0, the particle's starting position is somewhere over here. This is the starting position. Okay. So now the question is, when does the speed become 0 for the first time? So let's say we can also use phasor method to solve this. So that will be easier if I just draw everything in a circle. We'll draw one vertical line. Okay, so initial angle theta, initial phase value is pi by 3. At t equal to 0, it is at pi by 3 angle, which is somewhere over here, 60 degree, pi by 3. Okay, so this is the initial value. This is where the particle is on the circle. And if I find out its vertical projection, which means its vertical component, it will be a sine 60. So if you put t equal to 0, it will be a sine 60, exactly the same. So SHM, you can think of this particle moving along the circle the same as an SHM happening along the y-axis. Okay. So the thing is, when the particle, so if once t starts increasing, the inside angle starts increasing. So which means the angle, the particle will start moving counterclockwise. Okay, and when it reaches the top, when the particle reaches the top, at this position in SHM, it is basically the extreme position. So this is the mean position, this is the extreme position, and at the extreme position, what happens? The particle's speed is 0. Okay, so at the extreme position, the speed of the particle is 0. So when the particle goes from this location to this location, it reaches the extreme position, and then the speed becomes 0 at that location. Okay, so we want, when does the speed become 0? Okay, so now the time, finding the time is easy because all we need is this angle, and this angle is pretty easy. If this is 60, this angle is 30. Okay, and this phasor circle is a uniform circular motion, and the particle is rotating with the same angular velocity as this omega. So omega is 50, omega t, omega will be 50. So this time, the time t1, when the particle's speed becomes 0, will be this 30 theta by omega. So 30 degree, I mean we have to convert it into radians. So 30 degree is pi by 6, theta divided by angular velocity omega 50. So this will be pi by 300. Okay, that is when the speed becomes 0 for the first time. Now, when does the acceleration become 0? Acceleration is 0 at the mean position. Okay, acceleration is 0 at the mean position. So mean position is either over here or over here. So now the particle will continue on the circle. Okay, it will continue on the circle, and when it reaches the left edge for the first time, this is the mean position, and here acceleration will be 0. Okay, so how much angle did it cover? It covered this much angle. 30 plus 90, 120 degree. 120 is 1/3 of the total time period, right? 120 is 360 divided by 3. So total time period is 2 pi by omega. So this time t2 is 2 pi divided by 3 omega, angle by omega once again, and omega is 50. So pi divided by 75. Okay, this is when the acceleration becomes 0. So pi by 300 and pi by 75. So after pi by 300, the particle reaches the top of the circle. This is the extreme position where the velocity is 0 in SHM. And then after covering 120 degree, the particle reaches the left point on the circle, and that is the mean position of the SHM. Okay, so the SHM is happening along the y-axis basically, right? So when the particle reaches the top, it is as good as saying on the SHM axis, the particle reached the extreme position, and when the particle reached the left end, it's as good as saying the particle came to the origin, which is the mean position of the SHM. So that is how the phasor works, phasor circle works. Yeah, the concepts do repeat, but we can't predict which one of them would be repeating. So, but yeah, they definitely do repeat. Okay, so that is the SHM one. So that is basically it for today's lecture. Yeah. So that was around like 56 questions or something. Okay, so omega value 50 or 25, it will be 50. So inside that, inside the function, we have 50t plus pi by 3. So the omega value is 50. The coefficient of t is what omega is. Okay. Which state? I'm from Kerala. So will you take any classes for formulas? Formulas, I probably will. Like next session when I'll tell you guys about that when it. I'll have to recheck the schedule. So are these questions enough? I mean, the thing is NTA asks a lot of questions. So they can ask from anywhere, that's the issue. So there are a lot of topics from which they can ask questions. So we can't really properly predict everything. Like some more important topics other than these would be the capacitor dielectric one and capacitor and dielectric and the logic gates one. So they constantly ask those questions. So yeah, lecture was good. Thank you. And yeah, I'll maybe come up with the formula one, the most important formula ones maybe. Math session I guess starts at 6, right? Dipendra sir will take at 6 maybe. Okay guys, so we'll meet soon. So take care and all the best for everyone who has exams to come. So yeah, goodbye. Okay. Hello ma'am, lecture. Okay, खत्म. हाँ बंद.